This conference will now be recorded.
Hello everyone, welcome to our day 27 in our GCP Cloud Architect training. So where last week we finished all the networking concepts, the most important one we have covered it. I would say there are a few things which we have not covered, to be very frank, something like packet mirroring and something like traffic director. These are something like advanced one which comes only in the network engineering stuff. So and pretty new concepts, so that's the reason I did not cover it. The remaining everything we have covered. So if you just go to your networking section, if you just mouse over, you should be able to see most of them we have covered it. So just to give you a quick this thing, so if I just go to VPC network, external IP address. Bring your own IP was a new feature, so we have not even talked about that. Firewalls, routes, peering, network peering, shared VPC, serverless VPC access. We did not discuss about packet mirroring. It's an advanced one. So network services, load balancer, DNS, CDN, NAT is what we have covered. So traffic directory we did not cover. Service directory we did not cover. Cloud domain is a recently added feature. Private service connect is also a recently added feature. So advanced stuffs which is more towards the networking, we have not covered it. Uh, Hybrid connectivity, we covered all the things. Service tiers, we covered it. Network security, last week we finished it, where armor and SSL policy we discussed. Network intelligence, we covered basically the connectivity test. We covered those things. So, and few of the features in network intelligence, uh, where basically about the topology. So it's basically a visualization tool. So you can get a topology there. So in this, we have kind of tried our connectivity test features. So where we tried multiple options, internal IP, external IP, all those things. Um, Firewall insights, if you enable the firewall logging, you will be able to get these details, how many deny rules, all those things. So it's little self-explanatory thing basically based on the logs which you enable, you'll be able to get it. So except the one which I mentioned, most of the stuffs we have covered it, and this itself took us a good amount of time. The major portions is covered. Something which is slightly the advanced one for network engineers, like traffic director and packet mirroring, is something which we have not discussed. So if you're interested, do let me know. I can share you some links. Again, you can also get it in the YouTube, so it's nothing that uh, it's not difficult to get it. You can get it, and there are some Google Next videos also on that. If you are interested in networking to do more on this, you can explore. But these are slightly newly added features, so that's the reason I didn't even touch it. So with that background, if I go to the next slide, sure, I'll share the link, like just an information. The slides which was all updated, I have updated it in the Google Drive. Now you can look into all the updated stuffs. So you should be able to get it. So today when I send the mail, I'll send that in the email, the update, the links to packet mirroring and traffic director links. I'll send it in that so that you can make a copy of it. Okay. So you'll have a reference at least. I'll also change the email title so that you can keep it as a reference. So now we'll jump into a small set of quiz, folks, so that we can see how much we have understood. Not 20 or 30 questions, only around 4 to 5 questions is what I have, but really which is going to make you think to some great extent. So please make sure you change your mode to private or only to the presenter so that you don't send it to everyone. So the first question is, your company is building a large scale web application. Each team is responsible for its own service component. So one team does the back end, one team does the middle tier, one team does the front end application, one team does the machine learning component. So they have different departments, different teams. Okay. Uh, and each team is responsible for its own service component of the application and wants to manage its own individual projects. The projects here is basically the GCP projects. So they want to manage their own projects, meaning the front end, they want it to be in a separate project. The back end, they want it in a separate project, something of that sort. Um, you want each service to communicate with the other over RFC 1918 standard. So what is RFC 1918 standard? You should have been aware by now. We have used it a number of times. So meaning front end should communicate with the middle tier using RFC 1918 standard. Middle tier should communicate with the database using RFC 1918 standard. So the middle tier may also leverage some machine learning stuff again using RFC 1918 standard, even though they are in two different projects, or totally I would say four different projects. What could be the possible answer? Vivek already gave the answer before I finished it. Good, Vivek. Anil B. Aman got it correctly. So far, three of you got it correctly. I'm going to give you 2 minutes for this. Mangesh got it correctly. Anil Kumar got it correctly. Kumar got it correctly. Ankit got it correctly. Good. So, so either the demos or the concepts was really helpful. So most of you got it correctly. So the first and the foremost option, the key part in this question, I would say, is only this term itself, which is internal IP address. 10 dot address space, 172.16 address space, 190, 192.168 address space. Basically, they want to use internal IPs to communicate, is what they are saying. And this is what we have been practicing so far in our most of the demos after we understood those concepts and also understood that external IP address is going to cost a charge of $3 roughly. So deploy each service into a single project within the same VPC. Now, if we do this, it is not fulfilling the requirement which they told. They wanted it in different GCP projects. So if it is different GCP project, it's automatically going to be different VPC. So option A is not going to be a choice itself, and it's totally against what they want. If the customer says one and if you give something totally opposite, the customer is not going to be happy. So A is not a good choice. Option B, configure shared VPC and add each project as a service of the shared VPC project. So basically, if there are 4 projects or 5 projects, create a host project and add all those 5 projects as a service project, using which it's going to be only one VPC, but each of the team can have their own projects. They can work independently, but the communication is going to be using the same VPC. So it's same VPC, resources can communicate using internal IP address. So what they want is also fulfilled, and what is the requirement to communicate between the components is also fulfilled. So B looks like a good choice, as most of you mentioned. But before we finish or confirm B, let's also look into C and D. Configure each service to communicate with the others over HTTPS protocol. Uh, this could be sometimes an overkill, because whenever you introduce encryption, so you are going to have an additional stuff. So that's one important thing. And there is not much details how you're going to communicate. So just over HTTPS is not enough, I would say. Uh, Whether it's going to be internal IP address or external IP address. Per my understanding, with the understanding which I have, HTTPS protocol is going to be usually used by external IP address. Usually, that's what I have seen. Internal communication, doing it's going to be an overkill. It's going to be an overkill because it's all our GCP stuffs itself. If you do it, this is going to be an overkill. And remember, we had to do this uh, offload stuff, right? The encryption, decryption. So that is going to also take a hit. So maybe there could be a better option like option B, and it also does not give any details about how the projects are done. So that information is not there. So that's the reason C may not be a good choice. Option D, configure a global load balancer for each project and communicate between each services using global load balancer IP. When they mention global, it is very clear it is going to be using external IP address. The moment you use external IP address, RFC 1918 standard does not even hold good. So looking into the options, option B, as most of you mentioned, looks like a good choice. Good. So moving on to the next question. Please don't be in a hurry. This may look very simple, very basic question, but people will make mistakes. Don't be in a hurry. Read the question and then answer it. Don't be in a hurry. How many more VPCs one project have if it is already, sorry, there's a typo, if it already having default VPC? Okay, folks, read the question. You'll get something like this in exam. You'll make mistakes because you're super excited. So easy question. And I already see a couple of you made a mistake. So Anil B, Deepak Bandari got it correctly so far. You will get be super excited. So easy. And this is the same thing I wanted to simulate actually. Um, no, couple of wrong answers. So far only two of you got it correctly. The most simplest one, but we will make mistake. Mangesh got it correctly. Three answers wrong. And this really happens to everybody, folks, in the exam. So we can answer the most toughest one, but when it comes to the simplest one, we miss it out. Only reason is we are super excited. Oh, so simple. Aman got it correctly. Uh, no, two wrong answers. Now, basically, what is the question saying is, if I little demystify it, there's a project. The project is already having a default VPC. Now, how many more VPCs you can do? This is a question related to your quota. Which needs to be aware. So we can create up to 5 VPCs. So 5 VPCs are the max you can create in a project. So if I just go here to my quota, IAM quotas. So search for VPC network. Network or compute. Let me just search for it. So network, if I go to network and click on it, it says per project I can have 5 VPCs only. So what it indicates is currently I have 2 VPCs created. So if I just go to my networking, 2 is what it indicates. Let me just see whether I have 2 VPCs or more than that. 2 VPCs. So the quota is 5. So the thing is that remembering that quota is 5. So that's the default one which you get. So 1 is already there. So answer is going to be 4. So you'll be super excited to answer it. That's the reason I purposely put this question. So answer is C. Basically already 1 VPC is there and maximum or the quota which you have is only 5. So 5 minus 1, 4. Hope it is clear, folks. A couple of you made a mistake. Super excited to answer it, but simple. I have done this. I have done this later when I was doing the exam. So when I was doing, I would have reviewed it. I would have marked that for review. So I have corrected it because of just getting so excited so easy. Okay, so hope it is clear, folks. Moving on to the next question. Customer wants 60 gigabits per second capacity or bandwidth, whatever you want to call, between their data center and GCP. Which option suits their requirement? Anil Kumar, okay, so fast, 1 minute. Anil Kumar, Mangesh, Anil B, Vivek, Deepak Bhandari, got it correctly so far. Ankit got it correctly. Kumar got it correctly. How many offers we have there? Good. So a little high capacity, if you look into it, 60 definitely possible with our dedicated interconnect. Cloud VPN, no. You have to have n number of tunnels, close to 20 tunnels is what you have to support that, which is not going to be a effective solution. Partner interconnect. Why did you discard partner interconnect, folks? Why did you discard? What was your thought process to discard partner? VPN, we understand it's going to be really expensive. Partner interconnect. Good. So a partner interconnect maximum we had seen in our documentation itself, not in the slides. So as Kumar mentioned, we saw it in our slides. Maximum you can get up to 50 Gbps when you go to partner interconnect. So if I just go to partner interconnect uh, details, we had seen this. Uh, the capacity you go up to basically to 50 Gbps. Previously it was 10 Gbps. Now they have given it. So that's the reason I did not use my slides. I showed you in the table. So it's going to be maximum 50 Gbps only. That's the main reason why we did not take that option. So Kumar was correct. And cloud router is just a medium where it basically for dedicated interconnect, definitely cloud router is going to be used because they are going to use BGP, border gateway protocol, between those two networks. But just with cloud router itself, we will not be able to do it. So without cloud router also we can do it if we are going with static routing. So but that's not the complete one. It's just a part of the solution. So B looks like a good choice. So but by chance if it is like 40 Gbps or 30 Gbps, you should have some more details, I would say. If it is 30 Gbps, folks, what would be your answer? What would be your answer if it was 30 Gbps? You will think between dedicated interconnect and partner interconnect. Uh, but I'll still go with B only. Why? Is because they mention very clearly between my data center and GCP. Meaning, can it's very clear that they can reach out to Google's co-location facility, right? They can reach out to Google's co-location facility. Maybe it is again going to be B only. So maybe if they have added few things, maybe they are not able to reach the Google co-location facility, then you can think of partner interconnect. But it is in very simple lines they have mentioned uh, between partner between their data center and GCP. Maybe I would take basically B as a possible choice still. uh, and if you prefer to take partner interconnect, right, you may not get the same SLA like what you're getting in Google. So it's going to be different. And it cannot be more than Google's SLA. That is 100% sure, right? So the dedicated interconnect gives you 4 nines. So when you go via partner interconnect, does not mean it's going to give you 4.5 nines of SLA. No, definitely it is not possible. So it's going to be lesser than that. So if you want a lesser SLA, nobody's going to go with it. Only if you are not close to Google's co-location facility, then you go with it. So there are going to be little drawbacks, pros and cons with it. So dedicated interconnect, because the question is very simple there. So I would still go with B only. I just wanted to make you think basically, what if it happens? Okay, something of similar sort even came in my first certification. So something on the similar lines, just based on the capacity. So B looks like still a good choice, folks. If it's 30 Gbps also. Oh, sorry. So I had to change this. So I had put it as 20 first. So I changed it to 60. So it's going to be basically dedicated interconnect. The most interesting question, organization A and B both uses GCP for building their applications. Two different organizations, folks. Both wants to leverage GCP infrastructure and reduce egress cost. What does that mean? You should have understood it. What is egress? The outgoing traffic. Uh, what is the best option for applications in organization A to communicate with applications in organization B? Anil B got it correctly. Vivek got it correctly. Anil Kumar got it correctly. Deepak Bandari got it correctly. Mangesh, no, sorry, that was a wrong answer. All right, folks, let's do a small explanation. First option, VPC network peering. So, VPC network peering. Two GCP networks. It's very clear both are using GCP for building, meaning they are using GCP for their application development. So, from application A, which is in organization A, maybe in organization A, there's a project called project A, GCP project, and there's an application running. And if that application needs to access an application in organization B, which is in project B, and if they use internal IP address, we have seen in our last class, you can reduce the cost, egress cost to a great extent. If both are in the same region, for example, organization A, organization B, both are in Mumbai, and both of them use Mumbai A zone itself, egress cost is going to be zero. If both are VMs, it's going to be totally zero. That's what we had seen it in our pricing calculator. So, and if they want to communicate each other, because there are two different projects, the network needs to be peered. So VPC network peering is a good choice. Is a good choice, I would say. A is a good choice. Shared VPC is where a little confusion comes. What about shared VPC, folks? Why did you discard shared VPC? What was the thought, folks? Why not shared VPC here? There's one reason why I would discard, but I want you to answer it. Aman got it correctly. Vivek got it correctly. Anil B got it correctly. So it is within the organization only. But here there are two different organizations. Two different organizations. Uh, so basically, you need to have VPC network peering. It could be something like this, folks. It could be something like this. So RA, inside that you have project A, inside that you have VMA. Now if you, or I can make it still complicated. uh, mm, host project, let me make it little big so that this background is not there. So host project A, service project A. Now I have the B organization. Now within the organization, I'm using shared VPC. Shared VPC. This is going to work. But if VM A and VM B have to interact, basically I have to do peering, VPC network peering. Between what networks I have to do, folks? Between service project A and service project B, or between what are the networks I have to peer? So if it is this is a setup, we have to use network VPC network peering. What is that VPCs which I have to peer, folks? How many VPCs are there in this? If you can tell me quickly, if this is a setup, how many VPCs are there, or how many networks are there, folks? Is the question clear? Ah, okay. Anil B got it correctly. Anybody else? This is one network, folks. Host project is one network. So VPC A, you're going to have one more VPC, VPC B. That is a network which is going to be used by service project B, and VPC A is the one which is going to be used by service project A. Now there is only two networks. Now these two networks need to be peered. So VPC A needs to be peered with your VPC B. And now if you peer it, VMA is going to communicate with VMB. So hope this is clear, folks. Hope this is clear. Uh, so the same concept made it more complex. So I hope this is clear, folks. This is the same thing which they are asking. So within the organization, your shared VPC is going to work, but outside, if it's between two different GCP project, it has to be basically a VPC network peering. Okay. So hope it's clear. Thank you, folks. Um, so option A looks like a good choice. B can be definitely discarded because two different organization. It could be a part of the solution, but not the main solution here. Uh, how about C, folks? How about C? Create a custom VPC. What's your thoughts on this? What's your thoughts on this? I would say definitely this is going to be part of the solution. It needs the same organization. No, what I would suggest is basically, I closed it. Sorry. So if I can take that notes back, good that I saved it. So if I open it back, now when I create a VPC, right, it has to be definitely a custom VPC only, folks. So that custom VPC, it has to be a custom VPC, but just creating a custom VPC is not going to help me out, right? It is part of the solution, but just with a custom VPC, it's not going to be enough. You have to peer it. So this is a part of the solution. Shared VPC also could be part of the solution, but the main solution in this context, VPC peering or VPC network peering is going to be the good one. So applications into organization can communicate each other. Sorry, I made mistakes there here. So between each other with zero configurations and setup. So this is not going to work. So only if it is basically a default VPC, then it's going to work within the same project, not between two different organizations. So A, as most of you mentioned, is like a good choice. And I wanted to hint you that shared VPC is within the organization. The moment it goes out of two, it's between two different organizations, VPC network peering automatically jumps in. Okay, so option A is the good choice, folks. Last question. If you can answer it, I'll be really happy. Because I got something similar question there. So due to high security reasons, the VM does not have access to internet, understood, and is having only internal IP address, but an important OS patch needs to be updated. So it's just one virtual machine due to an external, due to a high security, they have not even provided an external IP address. We know if you don't have external IP address, you cannot do apt sudo update and do all the necessary stuffs, updates, patch the OS. What is the best recommended option? Anil B. Vivek got it correctly. Anil Kumar got it correctly. Kumar got it correctly. Deepak Bhandari got it correctly. Mangesh got it correctly. Who else we have? All right, folks, let's look into the questions, the options. First option, enable external IP address for a short time to access and install the patch. Maybe only for 20 minutes, give me external IP address. I'll install the patch and afterwards you can remove it, is what you're saying. So why you discarded this question option, folks? Any thoughts? Why you want to consider or why you want to discard this? Any thoughts on this? Any thoughts on this, folks? Why you, there are various reasons which I can say, but I wanted to hear from you why option A is not a good choice or why is option A a good choice? Nobody gave A as an option possibly. So why did you discard it? Any reason for it, folks? Security threat, having an external IP address, uh, strict requirement, no external IP address. So it's going to be against their policy if you do it. That's one thing. The second thought, which I would say is, let me wait, hear from others to see. So Vivek mentions security threat, Mangesh mentions strict requirement, so we cannot have external IP address. Other system will also get access to the system. VM have to be rebuilt. No, nothing to do with the VM rebuild. You can provide external IP address whenever you want, so that is going to be possible. Anil B mentions other system will also get access to the system. So security, upload will have restrict upload, you can control. Okay, so now what if I have done something like this, folks? If I can do so much strictness at a VM level, definitely it is going to be an organization, right? In an organization, I turn on my organization policy. No VM should have external IP address. If I do that, if I go to this, I don't have a this thing. 1 minute. Let me just open up my another account. It's manual, yes. Uh, First of all, that option can even not be enabled itself. So if I go to a project where I have an organization node, I have a policy applied. I apply a policy, organization policy. No VMs in my organization should have external IP address. So if I do external IP, yeah, here, define allowed external IPs for the instances. Now, if I go by default, it's going to be allowed. Now, if I put a policy like this, deny it, nobody is able to going to able to create a virtual machine with an external IP address. So meaning this option itself is not going to apply to them. So because I know people will do like this, so I would have put a strict policy. So whatever you do, you cannot have it itself. So then there's no point in saying that this is going to be manual, this is going to be have a security risk, all those things. We have totally mitigated it. So they cannot even create it. So it's totally blocked. So if you still allow them to do it, then it's going to be a security risk. Then it's going to be manually doing every time. So, and via this, you may get exposed outside. So that's the reason option A has to be discarded. So option B, upload the OS patch to Google Cloud Storage. Somehow you get an offline version of it, the patch. Somehow there could be some options to download it from internet, upload it to Google Cloud Storage bucket, and enable private Google access for that specific subnetwork. So where this VM is running, access the patch using gsutil command. So this is something exactly the same demo which we also did, where if you are using Google services, Google Cloud related services with private Google access, you should be able to access not only GCP services but also Google services like YouTube, all those things. APIs, you can access it with internal IP address. So it's going to be a better choice. uh, B looks like a good choice. The only thing is that the manual work is somehow get the patch offline version of it and then do it. So that's going to be an option there. So B looks like a good choice. Option C, just upload the patch to storage and access it with gsutil will not work, because if you don't do any extra stuff, by default private Google access is always turned off. Any subnetwork you create, private Google access is always default turned off. So if you turn it off and you try to access it, it expects, option C expects a VM to have an external IP address, expects to have an external IP address. So without an external IP address, option C is not going to work. So with the options given, I would say option B is going to be a better choice. And there's an interesting question in the chat where Mangesh is asking, is in this case, if cloud NAT would be an option, then it's going to be a right answer. So if there's a cloud NAT also provided, option D provides saying that have cloud NAT established, then I would definitely go with option D, because that is more easier for me, because getting an offline version of an OS patch could be a little tricky. So if option D was there, I could have definitely gone with NAT, Mangesh. So that's easier getting it, rather than doing a manual task of uploading it and then doing it. So uh, the reason why NAT was not put here was basically at that time uh, CloudNet was not launched. So CloudNet, if you just go look into the release notes, so in 2018 it was not at all there. So it was not at all there. So I did not even put it in. So it came recently, I guess 2019 or so it came. So if NAT is there, definitely I'll go with it, because it's more automated. I can just run a command in my Linux machine, it's going to, or Windows machine, it's going to get me the patch, only the outbound access. So in this context, option B is going to be a good choice. For people who mentioned option C, why it's not going to work? Because it needs an external IP address. We did literally a demo on this basically. Whole reason was to get this question answered. Okay. So if you want, you can refer. We have seen this private Google access option, private service access also we have explored it. So that's it, folks. So that brings us to the end of VPC concepts. So what we'll do now is we'll jump into our next module, module 6, where I would say from module 1 to module 5, they were foundations, basically introduction to GCP, cloud IAM, um, cloud IAM, then compute engine, the storage options, and networking. These are foundations, folks. It's going to be always there for you to help your GCP concepts to be clear. So that's the reason we took almost like 26 sessions itself to cover those foundations. Now you have your foundation very, very strong. So the upcoming modules, you will be able to get it very faster, easily. Okay. Thank you, Mangesh. So now let's look into the foundation, the next steps, big data concepts. Whenever you hear the word big data, what is that which comes to your mind, folks? Just for a minute, keep your GCP aside. Just go back at least like 3 or 4 years back, or 5 years back in your career. Whenever you heard the word big data, what was that which always came to your mind? Yes, so Hadoop, Spark, that is the one which would have come to your mind. So it was almost like synonyms. Big data means only Hadoop. That was the level of reach Hadoop did. It did really a good this thing, because you can do everything on a commodity hardware. You don't need a sophisticated hardware there. So that was a whole intent. And most of us know Hadoop was a contribution from Google to the open source community. So again, Google was involved behind the scene. So we will see the offering which Google also has equivalent to Hadoop. So what is that? So basically, whenever people think of big data, they only think of Hadoop. So that's totally true, as most of you mentioned. Now, I have a small slide just to compare your on-prem and GCP. This slide, for people who have not worked on big data technologies, may look like Greek and Latin, no problem. But when we finish this big data module, maybe 3 or 4 class from now, you should be definitely able to compare this very easily. So if it's an on-premise, you have something like Apache Hadoop, then in GCP, you get a equivalent of it. So still on the open source version of Hadoop. So latest version of Hadoop is 3.x if I'm not wrong. So it is supported by Google in a managed service, like similar to what you had MySQL Postgres. You want a managed version of it, you get it in Cloud SQL for MySQL, Cloud SQL for Postgres. Something very similar, you get it in GCP called as Cloud Data Proc. Now, what's the advantage of a managed service? You don't need to much worry about uh, installing dependencies, all those things. Just go run a Gcloud command, or run or provision it in a GCP console. It's going to get created quickly. So now, to be very frank, this first option was really a good choice for people like me, at least, because in my entire career, I have only set up once a Hadoop cluster on my laptop, and it took me almost like a half a day to do it. It was on a virtual. I use a Windows machine, so I had to create a virtual machine using VMware. Then I had to install necessary softwares with all lots of googling the results, the searching the results, and fixing it. So it was like just before I did a hello world example in Hadoop, it was almost like afternoon by the time I did it. So uh, meaning you're totally getting diverted to infrastructure, provisioning, all those things, rather than covering your or having your business requirement fulfilled. So that's what happens when you do anything in on-prem. But when it comes to cloud, right, that too in GCP, the resources which gets provisioned quickly is really a cool thing. So you will see Hadoop cluster getting created in 5 minutes or maximum 6 minutes. So after that, your focus is all towards having a business requirement, writing a Hadoop job in a MapReduce job, a pig statement, or anything Hive statement to get your job done. So that is going to be fulfilled very easily with cloud. So Google has a offering. So meaning if there's Hadoop jobs running, I can do a lift and shift to data proc. That is a name which Google gives. We know this. Google names are not really good, but nothing can be done there. So data proc is nothing but your managed Hadoop and Spark cluster. Similarly, Apache HBase, which is in the open source world. So if organizations are using it, we know Apache HBase was a contribution from Google. They have a managed version of it called as Bigtable, which we have already covered it in our storage class. Hive, if you have Apache Hive, you can do something. Hive is basically where you do everything using a SQL kind of language. So not everybody can write Java code. So if somebody is good at SQL statements, so on top of your Hadoop, you have a layer where you can do SQL kind of statements. That's where Hive comes into picture, Apache Hive. So if you were to do something similar on a huge data set, you want to query it, all those things, write a SQL query, SQL kind of query. Google also has an option called as BigQuery. We are going to talk about that. That's going to be our first module in big data, an enterprise data warehouse. It's not a one-to-one comparison between Hive and BigQuery, but the concept remains the same. Huge data and query, something of that sort. Or if you want to do something like on Dataproc itself, which is nothing but a Hadoop cluster, you can have Hive jobs. You can also have Hive jobs in Hadoop cluster in Dataproc also. Big statements, you can again go with Dataproc itself, which is again managed Hadoop cluster. Or you have something very sophisticated offering from GCP and also has an open source presence called as data flow. We'll see what is this data flow in detail, maybe in tomorrow's class or next Saturday's class. Kafka messaging service, so which is heavily used in on-premise. So if you want to get a equivalent of it, not an exact replica or a managed version of it, so an equivalent of that, you get a serverless offering in GCP called as publisher and subscriber, Cloud PubSub, a cool one where you don't need to do any setup, folks. And this falls under the category of a global resource. So far, we have seen only very few global resources, load balancers, VPC, firewall rules, routes. So and they were one of the building blocks actually. So PubSub is the next global resource which you are going to see. So that's something there. And if you have a Spark job for streaming data, all those things, because Kafka and Spark goes hand in hand. Anything when you want to do a streaming, the data is continuously streamed. Maybe data is coming from a sensor, an IoT device kind of a stuff, and you want to continuously process it and act on it. Then again, data proc could be a good choice along with or data flow. So what is data flow? I'll explain you as we go. So, but these are the options which is going to be possible. The reason for putting this slide was basically whenever it comes to huge amount of data, on-premise have limitations of the infrastructure, which can be easily overcome by moving to GCP. And you don't need to do lots of changes to the system. A lift and shift is possible in many of the requirements, basically. So that was the main message which I wanted to convey. It may look still like a Greek and Latin because this you would have heard these terms, but you would not have heard these terms because these are the first time we are looking into it. So we'll explore it once we finish the entire module. We'll revisit this. At that time the slide is going to become much clearer. Okay, to start with, in our big data category, we will start with a product called as BigQuery. BigQuery, a very important one, um, keeping all the architecture, all those things slightly apart. We will look into the details of BigQuery, because why we don't need to look into the architecture, I'll tell you later. So BigQuery, enterprise data warehouse, EDH, EDW, that's what they usually call in short form. So an enterprise data warehouse, just to give you some small heads up here, folks, like I worked in various organizations where uh, multiple GCP projects, all those things. Everybody has their opinion. Yes, this product is good, this product sucks, mixed opinion always. But there's one product where everybody says it is too good. Everybody says it is too good. It's for example, persons like Abdul Kalam, everybody praises him. So because he has done a great job, right? Something like everybody has one single opinion on him. So it is something similar. What I would say is BigQuery. So uh, at least one of the very senior person, right, whenever I used to interact with him, he used to always say, with respect to GCP, this product is good, this really is not good, this is a very tricky one, this is an expensive one. But uh, I've heard from him good appreciation, saying that this product is good. BigQuery. It was like so heavily used for everything they were proposing, always BigQuery. So this is a very cool product. Um, Very cool product, and many of them accept openly that this is really a good product, even the competitors. So that's the key part. And you would have seen also some Gartner reports recently which came, so where BigQuery was marked as the leader in enterprise data warehouse compared to its competitor like Amazon Redshift or Azure's data lake analytics. So this is a really cool product. Why? You will understand it as we progress. The first and the foremost thing, it has a good this thing. I guess this product has more than 10 years old now. So 10 or 11 years old now. So maturity is there, great. And I personally have worked on a couple of warehouse products called as Vertica. So when I worked in an organization called as Hewlett Packard Enterprise. So it was an acquisition. So I had used that product also. So the advantage of using BigQuery, we will discuss it. But for people who don't understand a difference between an enterprise data warehouse versus, many people make this mistake, folks, and a database. There's a difference which you need to understand. So an enterprise data warehouse versus a database. And I have seen even recently when I did a small consultation for a Google partner organization. So partner means you should have definitely some GCP skills. Only then Google is going to give you that partnership. So you have to have at least like 10 people certified in GCP. Then only that partnership is going to be available. So I had a small consultation work with them. So they were supposed to use a transactional database, but they were using BigQuery. So, and they were having performance issues. Totally agree there, because data warehouse is totally for, any data warehouse is basically for reporting, folks. It's always a good fit for reporting. It's not good for transactions. So database is always good for a transactional system. It's a transactional system, so you can do transactions. It's a transactional system. So it's having a two different requirements. So you should never mix up BigQuery with a database. To put it in very, very simple terms, uh, May month is going to come, so everybody is going to get salary. So 1st of May or maybe by 10th of May, you will get a salary. So when you get your salary, right, the information gets stored in a database. The salary information is going to be here. How much salary came, how much you do pay for your EMIs, all those things. So all this is going to be basically a transaction. So database is an OLTP system. Any database, MySQL, Postgres, Oracle, Microsoft SQL Server, all those things is going to be an OLTP system. Now you spend, now May month over, so maybe the entire year is over. Now say for example, you want to purchase a home, or so you want to apply for a home loan. Most of uh, the banks who's going to provide you loan, they wanted to understand whether you have that capacity of repaying it or not. So for that, they want to know your history, credit history, and how much you can repay. So they will definitely ask. This is a standard thing, at least in some of the countries. So get a 5 years bank statement. Get a 5 year bank statement. Then we will. This is one of the main document itself. If you're buying applying for a home loan, right? Now you may have. Uh, Aman, you have a question? Okay. Okay. So if you're applying for a home loan, right, even though you may have a highest privilege, like in every bank, right, you'll be called as a normal customer, a premium customer, a gold support, something of that sort would be there. Different tiers in the bank itself will be there. So based on that, you'll get some privileges, some points, all those things, right? Even if you have the highest privilege, like a gold customer, a platinum customer kind of a stuff, and if you want to get a 5 year statements, can you get it, folks? You may be having Citibank, HSBC Bank, something, any popular banks, any bank, SBI. Uh, you have the highest privilege because you maintain a good relationship. Can you get your 5 year statement on the fly? Go to your net banking and get it on the fly. 5 year statement possible, folks? 5 year statements. Anybody tried it? You cannot. You cannot get it. The reason is simple. Technically, the reason is This data is not in your relational database. The 5-year statements, if I keep it only for you, now if you see your own back statement, in a month you would have done like 50 transactions. Only one amount would be credited, everything would be debit. So only once we get a salary in a month, so everything is going to be debit. So you're going to pay EMI, you're going to pay your credit card bill. So you will have 50 such transactions. Only in a month, if it's 50 such transaction, in a year it's going to be huge. It's only for one person, it's only this much. And if a customer, if the bank is having around maybe like a good amount of like 100K customers, the number of data, the amount of rows is going to be huge. Keeping it in a database is going to become a performance issues. So that's the reason they offload this data. They offload this data into a system called as a warehouse. They keep it all the historical data. So this is an historical data. So this is an historical data which they keep it offloaded into a system called as warehouse. So that is the reason when you send a request, either you have to call customer care or raise a request in your net banking, and they will say we'll get back to you in 2 days, 2 working days, or 1 working day, something of that sort. The reason is on a nightly basis they run this report on this warehouse and get those data and they send it to you. So this is basically a OLAP system, online analytical processing system. So the warehouse is always used for reporting purpose to store massive amount of data, uh, and you should never do any transactions here. So it's only loading the data, querying the data. So not like going and deleting it. So if you do here transaction, right, you transfer money, maybe it's because of some error it gets issued, so you can delete it. All those things you can do. But when it comes to a data warehouse, you should always avoid any transactions of bulk load and bulk reporting. That is where you should basically use. So, and the reason why it takes more than 2 or 3 days for the bank to give you the report is basically it gets executed on this warehouse. So not every warehouse is so sophisticated to give you response in few minutes. So there are few warehouses which you would have seen. The most popular warehouse is Teradata, where many banks still uses it. It is a warehouse. Then you have Hexadata. Then you have Vertica. I have worked on this. So Snowflakes, which is now very coming very fast. So you have BigQuery, and you have Redshift, all those things. So these are all your popular data warehouse. What we are going to see is in GCP, the BigQuery, and you'll see a huge difference between the other data warehouse and GCP's one. The whole reason is BigQuery is totally serverless. It's totally serverless. And other warehouse, I have seen it, folks. I have seen it. Uh, if you were to close an opportunity for a warehouse deal, the only question which is going to be there is, I run a query, a SQL query. Most of the time in warehouse, it's going to be a SQL queries only. So if they run the query and they say this query takes 20 hours, 15 hours to generate the report. So if it's on a Monday, you need to show a report to your CEO. The report has to be started on Sunday itself. The query execution would be scheduled on Sunday itself. So on Monday, when you come to the office and you want to show it to the CEO or the CXOs, you can show it. So it has to be done so well in advance, because the system is not that optimized. But Google has that magic sauce with the help of BigQuery, where you can query terabytes of information in few minutes. So I myself have queried a 16 terabyte of data, which took roughly around 25 minutes. 16 terabytes, 25 minutes is easily a quick win, folks. So I have closed few opportunities in the Vertica stuff where they say on a Teradata it is taking 10 hours. Now, if you can make it 5 hours, I'm going to sign a deal with you. So that's how the customers usually sign a deal for warehouse products. The slowness is always the problem, and if you can reduce it, then they are going to buy your product simply. So that's a key part. And when it comes to BigQuery, your work is going to be reduced to a great extent because it is serverless, meaning you don't need to have any infrastructure. You basically load the data and start working. So that's the key part of it. So a small background. Now let's look into what is BigQuery all about. So a highly scalable, cost effective, fully managed enterprise data warehouse. And warehouse is always used for analytics, reporting kind of stuff. So it's going to be a OLAP system. Now, an important thing with a warehouse is not just dumping all the data, but also having some kind of an intelligence, built-in intelligence. So very few warehouse have this capability, the machine learning capability. uh, BigQuery also has a built-in machine learning capability, meaning you can write machine learning, you can have a machine learning model built using SQL, folks. This is one of the coolest feature you can get. So now if your data is in where Teradata, for example, or Netezza, Hexadata, or any other products if you have heard of. So if you were to do some machine learning, why do you need to do a machine learning? For example, let's take a simple example. A person's credit history is there. Now you want to run a model and say whether this person has a capability to repay or not, or he's going to default. So if you want to know that, you want to do a prediction whether Mahesh can repay or not. So this, to do it, usually what people will do, they will read the data from warehouse, load it into some system, maybe a virtual machine where they run some Python code or anything of that sort. Then they build a model and share it. But now what is happening? You're doing a duplication. You're taking the data out of warehouse and doing something. But if you have a built-in machine learning capability, the data is never moved out. Second reason, you don't need to have Python skill set. You can write a machine learning model in basically in your SQL statement itself. So which is really a boost, which is really a boost. And I've seen very few warehouse has this capability. Something like BigQuery has this capability. Vertica has this capability. Snowflakes to some extent is what I heard. But the traditional warehouse like Teradata, Netezza, they don't have it. They don't have it. So it's going to be a good win if you want to position BigQuery there. So BigQuery. So it has a built-in machine learning capability there. And the most important highlight is it's serverless. We have seen already good products in GCP like App Engine Standard, very specifically Cloud Functions, Cloud Run, Google Cloud Storage, Firestore or Data Store. These are all serverless products, and we know the benefit of serverless products. No setup, just go start loading the data like what we did in our data store. So what we did in our cloud functions, just go provision it, start using it. You don't need to worry about scaling it down, all those things. That's the beautiful feature. Now this advantage is going to be very, very important. Now, uh, usually warehouse opportunities, right? The customer will say, this is a 30 terabytes of data, which we are going to give it. Load this, give us a response, and they will give you some queries. This query, if it runs in so many minutes or so many hours, you will be the person who's going to take this deal. That's how usually the tenders in enterprise warehouse tenders are going to be there. Now if you compare BigQuery with Teradata, basically it's an appliance, folks. You have to have it on a dedicated hardware. It comes with an appliance, so then there is some software. So if you also were to do a proof of concept, you have to get this appliance to the customer place, load the data, first set up it, load the data, then start working on it. But when it comes to GCP, right, because it's serverless, you don't need to have any setup. You'll see that in our demo when we do it. You don't need to have any setup. The 30 terabytes which the customer has given, I'll directly load it and start working on it. So at least with respect to the other competitors, I'll be at least 2 hours ahead. Now, if you may be the expert in a enterprise data warehouse setup, but it's going to take 2 hours for you to set it up in a customer's premise, on-premise data center. Meaning, but if I come as a cloud architect with some BigQuery skills, then I will be at least 2 hours ahead of you. The reason is I don't need to do any setup. I just load it and start working on it. So I'll be always ahead in the race. The time is very important. If I can show it, there's a high chance that I may get a deal signed. So the serverless feature comes very, very handy. And the third point where it really, really rocks is it's not only for historical data. So the days are gone where it's only to keep historical data. I can get real-time data streamed and also build a dashboard on top of it as the data is coming. For example, gaming. Gaming. So huge amount of information is streamed, and I wanted to make sure, I wanted to know who's the top, uh, the leader in the game, which game is played the most. I want to do some various analytics using my BI tools like Click, Tableau, whatever it is. I can use BigQuery as the backend or the data source. Stream all the data. Google has that capability, or the BigQuery has that capability called as streaming insertion. I can insert it even before the data gets persisted. You can query it, folks. We'll do that demo also in our class. So even before the data gets inserted, at the end it's going to be stored on a storage, right? Even before it gets stored, I can query it because there is something called as streaming buffer. So I'm going to query it from the buffer, and you will never see as a BI guy whether data is stored in a buffer or it is in a storage, on a storage. So you're going to get the same results. So that's really a very, very handy option which you get. Real-time analytics, I can do it with
Uh,
BigQuery. And
my
yeah,
so if I want to store every day and if I want to run everyday file, if everyday report, then it's we can still use BigQuery, or it's not recommended BigQuery.
every reporting, whenever you're going to do reporting, BigQuery is always a good choice. So it could be few GBs or it could be few terabytes, Kumar. So if every day, say for example, let's take a simple example. So you have a banking website application where uh, you offload every last year's data. So you want to keep only 1 year. That's the reason you see in your banking, right? Only 1 year statement you can get maximum, or 1.5 years. So all other data would be offloaded. So offloaded to the this thing. So if you have that kind of a pattern, every day's content has to be offloaded. You can put it and you can query it. You can do it. So bulk load it and query it in a bulk. That's going to be a good fit. But if you try to go and insert a row, only a row, or update a row, that is not recommended. It is not that it's not supported, it's supported, but you don't get that latency, low latency, which you get it in a transactional database. Like insert, update, delete, all those things. If you do it, the fastness, you will not get it because the system is not built for that. And this is also a distributed system. So
But
for your use case,
but
definitely you can
but
use it. Yeah.
yeah, but my requirement is like every day I get a feed and I insert. At the same
Hmm.
time, at the end of the day, I run a report. So
The feed is going to
first,
be having a good amount of records, right? Is it going to be
yes,
one
yes,
record?
yeah. No, no,
Good
no. For
amount of
example,
thousand.
yeah, good, yeah, 1,000 records, exactly. Yeah.
Yeah, possible. It's a good fit. It's a good fit.
Okay. Okay.
So
Thank you.
1,000 records you insert it, and you want to do a visualization. How many people visited my website? I assume that is the data. So you want to have a visualization, you can do it. That's a good fit there. But uh, all those 1,000 records, you need to dump it in one shot. If you insert it like 1,000 inserts, totally not a fit. So you have to design it totally different to insert it in bulk insert. That's going to be a good thing. Okay, so you can do streaming insert, but if it's a batch, if it's a static content, like 1,000 rows are there, records, bulk loading is a preferred one instead of doing inserting one by one. So that's an important thing. Now, you already heard some good features: serverless, machine learning, streaming insert, all those things. It's a warehouse. Now, people who have worked on warehouse may get an idea, oh, this looks like a good product, but to be an expert in this product, should I learn something new? Is going to be definitely coming into picture. So the answer is no. As long as you know SQL, ANSI SQL, you should be able to easily work on your BigQuery. So no extra new learning is required. So the reason is BigQuery is ANSI SQL 2011 compliant. What and all the queries which you run in this specifications, you can also run it in BigQuery. So uh, BigQuery, that's the key part. So no extra new learning basically. So if you are already an expert on a database, so have seen in the previous batches, therefore few folks who worked basically on Oracle database, all those kind of stuff. I guess we may have some of you who have worked extensively on database. Now, if you wanted to have a change in the career, the way you have to position here yourself is a GCP cloud architect. Yes, you can create a blueprint, a robust architecture, plus you also have an additional skill, that is your database data warehouse skill set. Maybe you can look into this part. It's going to really help you out. A database migration from MySQL to Cloud SQL for MySQL, or if you have worked on data warehouse, Teradata to BigQuery migration. So which is really hot in the market, but only if you come from that background, you can see that value there. So this could be a good choice. And learning is almost zero because you already know SQL. You have worked on warehouse, so SQL is a main thing. So you already know it. So migration becomes easy where you use your GCP skills basically. So that's one thing. So it's SQL 2011 compliant. And last but one feature which I really liked, called as federated. There's one question. I heard some Oracle syntax are not working in BigQuery. Okay, Oracle syntax, when you mention itself, it is specific to Oracle only. So may not be ANSI SQL compliant, Mangesh. So if it's not ANSI SQL, it's something very specific to a database. Definitely, it's not going to work. It's definitely not going to work. So it has to be ANSI SQL. If so, for example, in Oracle you use PSQL, so there could be some specific built-in Oracle built-in functions that may not work in BigQuery, but the statements which you use, select, group by, aggregations, those standard stuffs which is part of ANSI SQL to 2011 specification, it's going to work. It's going to work. Specific things, if it does not work, you have to build a user defined function or something of that sort, Mangesh. Okay, so coming to the last but one, federated query, which is really a cool feature, which I would say, uh, using this feature you can make your favorite product Google Cloud Storage. So far it was only a dumb storage. Now you can make that storage intelligent by having a querying layer, a querying engine. So we know we can dump huge amount of data in Google Cloud Storage, structured, unstructured, semi-structured. If it's unstructured, nothing can be done, like a video file. But if it's structured, like a CSV file, or a semi-structured information like a JSON, you can run query on it. Make your Google Cloud Storage intelligent system. No more it's going to be a dumb system. We can make it intelligent. So you can query it, but the data still resides in Google Cloud Storage only. So you don't do a copy. So this is called as federation. You can easily do with Google Cloud Storage. A huge amount of data, you query it and show it on a visualization. Beautiful feature. Big table, which could be really one which you may really want to explore. Uh, if you remember our cloud bigtable class, we used few statement which was so weird, Greek and Latin kind of stuffs, like um, something like uh, create, put, scan. To create a table, it was totally a different command altogether. To because it had its own querying language. It's a NoSQL database. Now if you don't know NoSQL, but the data is in big table, and you want to still use a BI tool like Tableau to query a big table, what you can do is you can take the route of BigQuery. So it's going to be something like this. CBT, there's going to be an external, so CBT to your BigQuery to your Tableau. So something like this, you can have it. So BigQuery is going to act as an intermediate layer, which is going to convert your SQL statements into a non-SQL compliant version for your CBT. So this is going to be a good choice. So, and Bigtable is going to be very heavily used for any IoT related data, real-time streaming also it can support, time series data. So, but if you cannot do a querying using SQL language, you can definitely use this, because you need to know a NoSQL language. It's going to be a new learning for you, means you can use this, but the data still stays in Google Bigtable. Cloud Bigtable, not in BigQuery. So it's going to be called as federation, where the data stays where it is. There's going to be only one single source of truth, so no duplication, which is really a cool feature which you can leverage. We will see a demo on that on Google Cloud Storage. And you can also query a spreadsheet, folks. So in Google Drive, you can create an Excel sheet equivalent of Windows, Microsoft Excel sheet equivalent, right? Called a spreadsheet, which is from Google Workspace or Google Suite, G Suite. You can also query a spreadsheet in BigQuery. I have a demo in my YouTube channel. If you search it, you should be able to get it. Now the advantage, can you think of an advantage where a spreadsheet, you're querying it with BigQuery? One of the simplest option which I would say is, if you were to do a join between two tables, assume one table is in BigQuery, some sales records. Assume you are a product organization, you have only 20 products in your organization, and this has been sold to 20 million customers. Now you wanted to find out which product is the popular product, all those things, and for some business reasons, the product names kept is usually changed regularly. So for example, let's take a simple example. If you have a sanitizer itself, uh, which you were doing before this crisis, COVID crisis, now you want to do little marketing. So instead of just having a sanitizer name as XYZ sanitizer, you want to change the branding name, something like Protect Yourself Sanitizer, something of that sort. The name is changed, the product name is changed. Now what you can do is, anyway it's only 20 products, the name is going to be kept on changing, the product names, because for marketing reason you keep all your information in an Excel sheet or in a spreadsheet, basically in Google Drive. You can do a map, a join between your spreadsheet which is there in Google Drive and your data which is there in your BigQuery. Join it and get a response to see which product is heavily used, because in your BigQuery you may be using an ID, product ID, may not be the product name. The product name is in your spreadsheet, so you can do a join between it's going to be like more like a lookup table. So that kind of a stuff you can do it very easily when it comes to uh, Google Drive, the spreadsheet in your Google Drive, and a huge amount of data in your BigQuery. A very nice option to do a join. So federation is really important. We will see one such demo where we will use Google Cloud Storage as this thing. Big table, we will not do it. There's going to be some extra stuff. Google Cloud Storage is going to be slightly easier for us to do. And if you want to see the spreadsheet demo, there's a demo in the YouTube itself. You can look into it. The last and the most important thing, which shines very well, at least when you compare it between your other cloud providers, storage and compute are separated. This should be the base for any cloud solutions, and Google has used that very well. So the storage component, where the data gets stored, and there's going to be a compute whenever you do any querying. You send a query, there's going to be a compute required. So both are separated. So what's the advantage of separating it? Basically you get a scalability. So if more data needs to be stored, I only scale my storage. If more querying capacity is required, I scale my compute independently. But if you go back to the previous slide, where products like Amazon Redshift does not even support you that. So if you want more storage, compute also should be increased. If you want more compute, storage also should be increased. So they are tightly coupled, very traditional approach. But when you see BigQuery, these are two different are separated. So based on your requirement, you can scale either one of them, or if you want both, you can scale it. So they are separated. That's really a cool feature, I would say, when you compare it with your Redshift, at least with your Redshift one. Okay, so that's a quick overview of BigQuery. What we'll do now is we'll take a 10 minutes break, folks. Once we come back, we'll look into the architecture at a very high level and see some of the important features in it, then jump into a demonstration. Okay, so take a 10 minutes break and come back, folks. So where's my timer? Yeah, take a 10 minutes break and come back. Let me stop the recording.
This conference will now be recorded.
So before the break, we saw some highlights about a quick overview about BigQuery. Now let's look into an architecture. Now, before we go into this architecture part, I just wanted to give you one small information. So we will not literally spend a good amount of time on the architecture, how the things internally works, how between the storage and the compute works, all those things. We don't need to know it. Simple reason, it is serverless. Even if you know it, you'll not be able to leverage it fully. You don't have much knobs to turn on and turn it off. There's going to be very few knobs. Okay, so that's the reason this architecture is going to be very, very high level, and you don't need to look into the details. And there's one specific section where you can spend definitely a time as a warehouse guy, as a cloud architect. If you want to give some thoughts, you can give it. Basically, that is where the query optimization needs to be taken. So when we do the querying, I'll definitely show you that. So with that background, let's not go so deeper into the architecture, but at a high level, how it works, we'll see. Okay, so a decoupled storage and compute option. So storage is going to be a distributed system, and it is somewhat equivalent to your Google Cloud Storage, which is going to have 11 nines of durability. And your compute option, why do you need compute? We'll see it when we see the actual demonstration. So storage is where actually your tables get stored. Simple. So now if you want to access a table, you need to run a query, select column names from the table. So when you run that, a compute option is required. There is going to be some compute engines. In very, very simple terms, few compute engines are going to get provisioned on the fly, run this query, show you the output, and they are going to get deallocated quickly. So that's going to be your compute option. So there is an internal name which Google calls it as, called as Dremel. So BigQuery has also an internal name which is called as Dremel. So if you see any YouTube videos from the Googlers, they usually use this word Dremel because that's the internal name. So that's your storage and your compute. They are separated. Now, if you were to communicate it, then you should have a network. So the network, because it's internal, so you can have a petabit network. So you will see that latency very, very less. It's petabit network. So this is how your storage and compute are connected. That's the main heart of BigQuery, basically. So how data gets stored, all those things, let's not even worry about it. They get distributed easily. So distributed easily. Now that's your main architecture. Now, how do you load the data? Basically, you do loading the data in two different styles. Bulk loading. I was very particular in saying bulk loading. The reason is if you do one insert, like your database, insert, insert into table, the column names and values equal to this. So if you do one by one, it's not going to be a good fit. And there's going to also have some limits per day. You can, how many inserts you can do. But when you do a bulk loading, meaning I have 20 million rows in a JSON file or in a CSV file or in some other formats which we are going to see, it's going to be totally free. Loading the data is totally free. There's no cost. Why do you think this is going to be free is going to be important? If you remember, if you have, we saw products like Cloud SQL, Sunner, all those things. Those are managed service, folks. The moment you create your Cloud SQL instance, whether you use it or not, you need to pay the bill. So for there, every activity is not going to be charged. But if it's a serverless product, every activity is going to be charged, right? So loading the data is totally free. But when you do a streaming insert, basically, then it's going to be charged to a little extent heavily, I would say. So there are two ways of loading the data, streaming and bulk load. Bulk load is totally free, and most of the demos which we are going to do is going to be using bulk uploading only. We are going to use only once a streaming insert when we do maybe tomorrow the demo. So that's how the data enters BigQuery. Then once it is in BigQuery, what are the ways you can access it? So you can use your standard SQL statements. standard SQL statements to query it, and you can query it in a command line mode, the same SQL statement, or in a GUI, that's our web console, or using REST APIs. And also you can call it using the client libraries. We have around 7 to 8 client libraries like Python, Java, C Sharp, Go, PHP. So you can easily query it. So if you want to have application which can query it, you can also query it using this client library. So that's how you query it. So what we are going to spend time
Mahesh,
more. Yeah,
Mahesh,
just
when the data storing, it stores in any encrypted format or anything, or it's just
by
stored like.
default it's going to be that is always standard. So encryption is always turned on by default. So whenever you talk about storage, Google is going to provide you at least the basic version, Google managed encryption. So that's going to be there always. So it's going to be encrypted. So nothing is going to be stored in a plain format in GCP. So encryption is turned on by default. You also have one more option, which is a customer managed encryption key. So where you can provide that also. So by default, if you don't do it, it's Google managed encryption. Data is going to be stored in that fashion only. It's encrypted and stored, and that too, it is going to be uh, the records are going to be split. Each records are going to be encrypted. So you don't need to worry much about the security part of it because it's already taken care, Kumar. So uh, what we are going to do is we are going to spend more time on loading data, streaming the data, and we will use only web UI, that's our web console, and command line. So we'll not query it using a command line, using a program. If you're interested, I can show you that. Focus is going to be more on querying it. So in very simple terms, what you should be thinking of a warehouse is, if it's an enterprise warehouse, what you are going to do always is bulk load and always use select statement. These are the only things we should do. If it's a database, basically you can do create, insert, all your DML statements, DDL statements, update, delete, select. You can do all those things. But in BigQuery, basically in our BigQuery, avoid as much as possible update, delete, insert. You can do it. It's not that it's not going to support. You can do it, but it's not recommended. And this is the same rule of thumb which you use even in any enterprise data warehouse. So you should not do these things, because this is going to be like say for example, if you do update, basically you want to update your transaction which has already happened. If you provide this kind of update option, right, somebody can go and update their transactions in the warehouse, right? So that kind of a stuff should never happen. So it's going to be a single source of truth. So avoid doing updates, delete, inserts, single inserts in warehouse. Bulk inserts, bulk selecting is always a good choice. That's the main purpose of an any enterprise warehouse, basically. And that's what we are going to spend. We are going to spend more time on different types of select statements, different types of optimizing it, all those things. And as I mentioned, this product is becoming very, very popular. People are doing lots of migration from their existing warehouse to GCP's BigQuery. Google understood that. What they started is in last year, 2020, Google Next event, they launched a product called as BigQuery Omni, which is going to be a multi-cloud analytics platform. Basically, you can have AWS. So you can have AWS S3 storage bucket. So the Google Cloud Storage equivalent, you can have the data in S3. Then you connect between your AWS and GCP, then start querying it. So the data which is there in S3 bucket, you are going to query it. So that way you are going to have a multi-cloud analytics platform built in. So in simple terms, the whole stuff here is saying like you don't need to use Redshift, which is the equivalent of BigQuery in AWS. So you can use BigQuery Omni, uh, very little information is available. So it's still in alpha or beta, if I'm not wrong. I guess it's not in beta, but it's still in alpha stage. But just wanted to give you that small heads up. They're not going to ask you questions on BigQuery Omni, to be very frank, because it's still not a GA product. So I checked the documentation. I was not able to get what is the current state of it yesterday. So if you can get it, let me know. So it's a new product. So similarly, they are going to bring Omni, BigQuery Omni for Azure. On-premise, it is still not there. So they may come up with an on-premise offering. So basically, if you see the strategy which Google is trying to do is they understand it's going to be multi-cloud, hybrid cloud concept. So that's where products like Anthos, all those things are coming into picture. So Anthos, BigQuery, Omni, all those things are coming into picture. So just to give you a small heads up, same architecture, the storage is going to be different, and you try to leverage it basically. Now, what we'll do is we'll do a series of demo where we understand from the basic, go to some complex understanding, like complex concepts like partitioning, clustering, all those things. Even if you're not from the background, I'll make sure I'll help you understand those little jargons, and also we will do a demo. So almost like 10 or 9 demos is what we have. So these are all the demos which we are going to do. So we'll first start exploring a public data set. We'll explore a public data set. Then we'll understand what is that one thing which you should never do in BigQuery. Not only in BigQuery, in any warehouse. That is select star. Why, if you do select star, it is not recommended. We'll understand it. We'll also understand how to load data. Different formats we will try to load it. There are different formats. Then we will also explore keeping a data in a Google Cloud storage bucket. How can I make it intelligent? Make my storage bucket intelligent, smart, by putting a querying layer on top of it. Then we will understand concepts like partitioning and clustering. And lastly, we'll see how we can expire a partition. So if you don't know what is partitioning, don't worry. We'll make sure we'll understand it. Okay. So series of demo, maybe it's going to take around 4 or 5 hours to do all these demos. So first, let's explore our public data set. First, let's go to BigQuery console and see how it looks like. You can have the same expectation which you had for any serverless product so far. It's going to be the same thing. No need to mention anything. So just go loading, load the data, start querying, something of that sort. So if I go to my home screen, so because BigQuery falls under the big data category, so you have to go to the big data category, big data. So you're going to see good amount of products. We are going to explore also good amount of products. One of the product which we are exploring today is BigQuery. So click on this BigQuery. You get this user interface, folks. This user interface is currently in preview, not a generally available user interface. So you may see some glitches in this user interface. But there are some cool features in this interface. You can have multiple tabs, all those things. So for now, for our demonstration purpose, I'm going to click on this hide preview feature. Now, if I click on hide, it's going to show me a generally available user interface, which is little stable because it's generally available. So this is how the user interface looks like. So if you want to show back, see your preview, you can click it back. You can click it back. There are certain features which I was not able to explore it in this new one, little less documentation. So that's the reason I am relying on my generally available user interface. So this is something which I've been using for a good amount of years. So a little comfortable here. That's the only reason I switched here. Okay. Now, this is how the user interface looks, folks. A main screen where you type your query, select statements, you put your select statements, and you click on run, you're going to get the response. That's it, nothing else. So no need to provision anything or anything. So just go and start querying. Now what we'll do is, for the first time, we wanted to query some data without loading anything. We wanted to query some data. Now this is where again Google really gives you good amount of uh, inputs or data for showing that BigQuery really rocks. So let's assume you are in front of a customer. Do we need to have a separate role for BigQuery? We'll talk about that, Kumar. So we have to have a separate role called as BigQuery admin. We'll talk about that later. So first, let's understand BigQuery concepts. There's a slide on that also. We'll do that. So when it comes to showing, so assume you are in front of a customer and and you say good things about BigQuery. It is very fast. It can give you response in few minutes. And let's be very realistic. It's not going to be in seconds. It's going to be in few minutes only. Uh, it's serverless. It can do petabytes of data, easily query, all those things. You can give all those nice fancy slides, all those things, but customers are going to expect you to show you a actual demonstration. Only then they are going to understand it. Now if they say we want to see this in action, now the follow-up thing, if they ask us a follow-up question, can we see this as an action, querying a petabyte of information or a terabyte of information, can you show it? Now if you ask if you can share your data, we can definitely show it. Now no customer is going to provide their data in the beginning itself. They will say we work in this sector, the sector in which we work. Assume they work in a transportation sector. Take any sample data which is in the same sector, query it and show us. If we are satisfied, then we will share our data. So this is sharing this data in a warehouse opportunity is always like a chicken and egg story. You have to show that you have the capability, the product has the capability. When they understand that, then they will share the data. Now where will you go for a petabyte of information? So to make your job simple, what Google has done is they have uploaded good amount of public data set, which is stored somewhere in a Google project, which they have given you access, a read-only access, which you can go and query it. So let's explore this public data set. This is going to be really helpful for you to explore the BigQuery concepts and maybe to show to a specific customer to add a public data set in the generally available user interface. You can click on this option touch. So you can click on this add data. You will see explore public data set. Weather is also available, Anil Kumar. So you should have that weather report. I'll show you that. So if I click on this explore public data set, it's going to open me the various sectors where data is populated by Google. So various, and even about COVID is also there. So they get streams, Google data from Europe and US about the various status of COVID. That is also going to be there. So if you want weather, you should also see some weather related stuffs. If I can see something, yeah, climate. So you see some climate related information about how uh, the climate looks in a specific uh, place for over 30 years or 20 years of that time. So you get good amount of data sets which you can try. Now the customer is in a specific sector, any of these categories, you take it. For example, if they are in transportation, something of that sort, you take it and explore it and see whether the data is very close to them and use it. So this is a good place to start exploring BigQuery. Now, since we are doing it for the first time, right, I will never ever take a very big data set. I'll always take a very small data set. Why? I'll tell you once we finish this demonstration. So first time when you're doing it, and now when you're in front of a customer means you're already like an expert. That's the reason you are been hired and you have been positioned as a cloud architect. Now when you're learning, right, always start with a smaller data set. So one of the smallest data set which I have seen is if I search for NYC city bikes. So basically this is a bike sharing app where bikes are going to be in your metro stations or your train stations where people can take this, hire it and get drop it in another metro stations. That is the data. So this is the data all about. So you can click on it and you can get the details about the stuffs. What is this data? And it is an older data, last updated on uh, in 2020. So now if you want to see this information, you can see the details. What is this all about? What is the content? All those things. It's open sourced. open source. Now, if you want to view the data, click on view data. So when I click on this, what is going to happen is on your left hand side, if I just go back here, the other tab which I had. So when you started, right, there's nothing except your project ID. Now, after adding your data set, you see one more data set. After adding that, you see this new entry. This is nothing but a project, folks. BigQuery public data is nothing but a GCP project ID. Inside that project, you have a data set. Inside the data set, you are going to have few tables. The table which I selected, if I scroll down, was under a data set called as New York City Bike, and inside that specifically there is a table called as City Bike Trips. So this is the hierarchy. The hierarchy is going to be something like this. So your project, there's a question, I'm going to answer it in a minute. Project ID. Inside that project ID, you are going to have a BigQuery data set. Inside the data set, you can have a table. The table is going to have rows and columns. This is how the hierarchy goes, like, basically. So there's one question: do these data set give the amount of data in them? Yes. How much data is there? You can come to know either by looking into the description of the data set, Deepak Bhandari. Otherwise, there's a command which you can see, or there's an option where you can see how much rows of information, how many bytes of information, or kilobytes or gigabytes of information is there. So you can get that information very easily. That's what we are going to do now. So this is the table, folks. This is the table which I wanted to explore. There are two tables: city bike stations and city bike trips. Now this is the table information. So whenever you look into any table information, right, make sure you explore the data set. What is the schema? It has a station ID, name, short name, blah blah blah. It has around, like, roughly around 15 plus columns. It's a table at the end. Now, to answer Deepak Bhandari's question, if you click on the details of the table, you'll come to know the complete information. The complete information is, this is the table ID: project ID colon data set name, which is New York City Bike dot your table name. And what is the size of this table? 120 kilobytes only, folks. Only 120 kilobytes. It has no more than 937 rows. Created on this time, last modified on this time. And the data is stored in US location. So this details is going to help you out, Deepak Bhandari, on what is the amount of data it has. Similarly, if you wanted to explore some other data like city bike trips, if you explore it, go to your details, it's going to show it has almost like 58 million rows. 58 million rows, almost like 7.5 GB of data. Last updated was on September. It gives you that complete details. Now, going back to the smaller data set, you see the schema, understand what is the schema used for, what are the column names, the value, the details of it. They have nicely documented it. So clicking on details is going to give you the rows. I always, when I explore any new data set, I always come and explore this tab, folks, the details tab, to know what is the row, what is the size. The reason is, in BigQuery, it's going to depend on how much data you're going to query. So this is going to give you a hint. Okay, is this a big table or a small table? Huge amount of number of rows are really high or less. That's going to give you this idea here. Now, if you want to usually see the data, what are the values, what are the various station ID, what are the various values of name, usually people will do select statements. But in BigQuery, if the table is stored in BigQuery in a native form, you don't need to do anything. Just click on preview. It's going to give you a preview of all the rows. You can do navigation. You can see it. Now this preview is totally free of cost. So, and all the stuffs which I did so far, clicking on the metadata information like schema, the details, doing a preview, these are all totally free. So I have not even incurred a single cost in doing these activities. Now you see the content. Okay, you are happy. Okay, this is how it looks like. Now the preview shows everything. All the, how many columns? Roughly around 12 plus columns. It's going to show everything. But you are going to do some kind of an analytics where you may not be interested in all the stuffs, all the columns. You may be interested in a station ID, station name, latitude and longitude. That's it. You have something with only these 3 or 4 columns. You wanted to query this, then definitely preview is not going to help you. Then you have to definitely put a select statement. So let me put a select statement. So the way you put it is, there's an interface here called as query your table. Just click on this query table. It's going to bring up a statement automatically for you. Select, you need to mention the column names from BigQuery. You see the entire table name is going to be mentioned. BigQuery hyphen public hyphen data dot the dataset name dot the table name. And when you're querying, right, please note it is separated by dots. Project ID dot dataset ID or dataset name dot your table name. It's going to be dot separated. Please remember it. It's not colon separated. In the details, it shows us colon. It is something little confusing. So, but when you look into the actual table, the way you address it is always dot separated. Remember that. And there's going to be a command called to query. So anyway, I have only less than 1000 rows. So this limit is not going to be of no use there. So if you want, you can keep it. Otherwise, you can remove it. So it shows you this command. Before you run it, it's going to show you there is an error. The reason is you have not supplied select list must not be empty, meaning basically you should put the list of columns which you want to get. You can explicitly put the columns, or in the beginning everybody is going to do this select star. If I put select star, it's going to show basically the command is valid. So, and BigQuery is also going to do a dry run, folks. Let me repeat, this output, this information which you see is called as dry run. It gives you a information when you run this query, because it's all serverless. Every query is going to be charged, folks. Every query is going to be charged. So you need to make sure the query which you run is not going to be heavily charged. Cost optimization, you have to do it. It's not like your SQL world where you have already purchased the infrastructure. It's up to you how much queries you want to run. But this is a serverless product. So same like your data store or Firestore, where each and every query is going to be charged. So what is the query? So if I run this query, select star, it indicates it's going to process 121 kilobytes of data. So it may take around 0.1 second or 0.2 seconds or something of that sort. So to process it, so for that you need to pay a cost. This is how the entire billing model or pricing model works. So how much is the data you query, how long it took, for that you need to pay. Basically a simple model, pay per use. Now this number, where did it get it? If you wanted to know that, so that's where your details is going to help you out. So does it match here, folks? What you're doing is a full table scan. By putting select star, you're doing a full table scan. So select star is going to do that. So let me run this and see what is going to happen. So it's going to give me basically the same set of results which you see in preview also. So, but preview was totally free. But when I run this query and click on run, it's going to basically take a couple of seconds, 300 milliseconds it took to process the data. Very short data, and I did it. Now, this is based on this only your billing is going to be charged. You will be charged. So how long it took? So for 0.3 seconds, there was a compute engine which get provisioned, a kind of compute engine, not exactly a compute engine. There's going to be something like servers which is going to be in standby mode. So your compute option goes to come for 300 milliseconds. It's going to be used to process this data. Afterwards, it's not going to be used. So data is going to be queried and it's going to be shown to you. This is basically how it works. Now, by putting select star, what you have achieved is always a full scan. Now here it was very small data, absolutely fine, no problem. But assume for a minute, if I go to this other data set, BigQuery, sorry, city bike underscore trips, it is 7.745 GB of data, 7.47 GB of data. If I query this, and put select star, what is going to happen, folks? It's going to do a full table scan, which is going to read 7.5 GB of data. Definitely it's going to take some time to get it. So maybe I can run it quickly and show you how long it is going to take. It takes around 0.4 seconds to query it. Now you may see 120 kilobytes of data takes 0.3 seconds. 7.5 GB of data takes only 4 seconds. So that's the magic of Google or BigQuery. The system is distributed. It can handle this very well. But the key part is, how much you will be charged. How much you will be charged. You can come to know how much you are charged by clicking on this query history. So on clicking on the query history, you will come to know each query cost. So if I click on the first one, so at 7:59, when I run this query, select staff from city stations, it took this much cost. The bytes processed was 20.97 kilobytes. That was the only bytes which was processed. But BigQuery charges you minimum 10 MB. Minimum 10 MB. Like how if you create a virtual machine and stop it within a minute, you'll be still charged for a minute. Afterwards, it's going to be per second. So, but 1 minute is minimum billing, right, for a virtual machine. Same thing happens to BigQuery. So when you run a query, if the query is going to be less than 10 MB, you will be still charged to 10 MB. So our data was less, so we still need to pay 10 MB cost. So the bytes build is 10 MB. Now, if I minimize this and go to the other query, now you see how much was that, the other query. So the bytes build is 7.74 GB of data. So meaning the volume is more means your bill is going to be little more. So if you go to your pricing calculator, and go to BigQuery, how the billing looks like, you'll get an idea. So there are two models on demand. That is what we are doing on the fly whenever we want. So the pricing is always based on how much data you're going to store, how much is your query price. For example, you queried 7.5, 7.47 GB of data, right? If you put it, this was the query price. So make it as GB, give a name, storage price Y0, because the data is not stored in my project. It is stored somewhere else, folks, by in some other project. So storage price is nothing, but I just queried it. So this was my data. So if I click on add to estimate, so this is totally free. This is totally free. The query which I ran is totally going to be free for me. Why? Because Google provides you 1 terabyte of querying free every month. So meaning if I go back, put 1 TB, is going to be free. 1 TB of data is free. Now the moment I slightly exceed it, So if I make it as 2 TB, you'll see $5, folks. You'll see $5. So 1 terabyte of querying is going to be totally free in a month. So beyond that, it's going to be charged. So that is what it indicates basically. Now we can do some optimization. So we may do this optimization. Now once if I run it, it's going to be 7.5. Every day if I do it, it's definitely going to exceed my this thing. So if I do 30 days into 7.5, it's going to be around 225 GB. Now if it is done by say for example 3 BI stuffs, or 3, or say for example by 5 people, or by 10 people, so it's going to be 2.25 terabytes. So then definitely it's going to start incurring cost because you're doing select star. So a rule of thumb when you do something in a warehouse is never ever do select star. The reason is the data is distributed. The data is distributed, at least in GCP BigQuery, it is a columnar data store, meaning if you see BigQuery trips, this is the table which we are exploring. No, sorry, stations. So it has around how many columns? 1, 2, 3, roughly around 15 plus or 16 columns. Now each column is going to be stored as a separate files and encrypted, all those things. So that's where a columnar data store comes into picture. So it's a columnar data store. So when you start putting select star, it has to read data from all those 15 or 17 plus files and then show you the result. So it's going to process all the data. Now if your requirement is only query few columns, you can change it. You say I want only, if I put select star, it's going to do always a full scan. We know that now. So if I put only station ID, there's a trick which you can do. You can just click on the names. It's going to come there. Name, latitude, longitude. Now you are only reading 4 columns. One is of type integer, string, 2 are float. Now look at this value, folks. Look at this value. Now by putting exactly what are the columns you need, the amount of data which is going to be processed is going to be reduced. So the key takeaway is never ever do select star in a BigQuery table. Unless you are going to query all the table, then it makes sense. But it may have 20 columns, 50 columns, but you are only interested in only 5 columns, then always put explicitly the column names. You can reduce the query cost. So is this part clear, folks? You see that very clearly. The moment you put a lesser columns, the amount of query it's going to do is going to be less. So this is the rule number 1, folks. Never ever try to put select star. I guess this is the last time which we put was the last time which we are going to see. We will never put in our, at least in our training, select star. It's a best practice. So always avoid select star, not only in BigQuery, in any warehouse. So in any other warehouse, it's going to impact, it's going to have a performance impact. In BigQuery, if you put it, you're going to incur more cost because it's a serverless data warehouse. So I hope this part is clear, folks. Not to put select star. We explored our public data set. We explored the columnar data store structure, and we understood you should never put star. By doing an explicit demo itself, we understood it. Now, for example, if I go to city bike trips, if I remove this, so this table is of 7.5 GB of data. Now I can, if I'm interested in very few columns, maybe I'm not going to query 7.5 GB of data. Now let me just query it once. Trip duration, I may be interested in station ID, station name, latitude, longitude. Look at this, folks. Only these columns is what I was interested in. From 7.5 GB, it has been dropped to 2.6 GB of data. Simple. So this is the beauty of BigQuery. So always make sure you never put select star. Now I wanted to share a real experience in one of the organizations where I joined. Um, um, all were data engineers, folks. This is another certification which you get in GCP. All were certified data engineers from Google. It was a partner organization, Google partner organization. So there, when I joined that organization, so I was just exploring one of the BigQuery table, some projects I was just exploring. So I just went into the query history just to see what these people run out of curiosity only. So what these people run as a query, I just went into my project history and saw the details. So personal history is what queries you ran. Project history, if you have a privilege to see all the queries which others have run. So luckily in that organization, I got a privilege where I can see other queries, what people have done. So basically a little broader role. I was just curious to see, and I was very shocked to see every query, right, was always select star. And they call everybody themselves data engineers. And some people were so adamant, uh, they were putting their signature like data scientist. There's a difference between data engineers and data scientists. So they did not understand it, but they were so very proud of themselves that they are data engineers, data scientists. But they were not using the concept which they had learned in the official materials or the trainings which they have learned. So they put select star everything everywhere. Then I had to write a mail saying that what you have learned in your certification process, you are not using it in your day-to-day work. Putting select star is going to incur huge cost. Is going to incur a huge cost. I took some screenshots, shared it, then they realized it to avoid putting that. So that way, the bill in the next month reduced to that organization. So uh, just learning the concept, not clearing the certification is not a big deal, but using it in day-to-day work is an important thing. So at least giving you this tips, right, you would avoid, at least I would say. So never ever put select star, folks, and that too in front of a customer just to query anything. Never ever put it. Okay, so never ever put it. And if you put select star in front of a customer, the customer will definitely understand your knowledge is very, very limited. And that's the reason you will see any Googlers doing a demo on BigQuery. There are good amount of videos. You will see they will never put a select star. They will never put a select star because it's going to incur a huge cost for you. Okay, so never ever put that. So that's the main thing, folks. No to select star. Select star. It should be select column names. Select column names. Okay. Now good, we showed, assume this is like a customer, we showed you see the capability of a BigQuery. It can query the results quickly, easily. Now the customer may be impressed. Now he's ready to share his data. Let's assume he's ready to share the data, and he provides the data in a CSV format, comma separated value format. So let's load that data. The data which you used, folks, was a public data set, not a data which you had. Now public data set is going to be really helpful for basically for learning purpose. But when you want to use a real want to apply it, it should be applied on your real data, right? So let's see how we can load this data. Okay, so all this data sets is there in the Google Drive. So module 6, you should be able to get it. So let me open up that data set, which I also have it. So if you go to your BigQuery data set folder, you should be able to see all these files, folks. I have one of them. So first let me open this one. This is how the data set looks like, and it's not a very big data set, and please don't laugh at the data set, the number. It's only 9 rows, folks. So let's start understanding loading smaller data sets in the beginning, because every query which you are going to run is going to cost you. Now if I had started my stuff on a big data set like a terabyte or 15 terabytes of data, and I had done select star, what would have happened? What would have happened? My free trial would have exhausted. So if I go to my pricing, so if I run 15 terabytes of data, What's going to be the cost? $70, folks. $70 is going to be exhausted in one single query. So I did not want to do that because your credit is going to get exhausted. So it's almost 3 months. 3 months only you get it, $300. So in one query you can exhaust $70 easily. So never ever do that. And that's the reason we will always start with smaller data set. Slowly, when we advance to the final demo, we will come to GBs. We'll never go to TBs with the data set which we are going to explore. Only because we wanted to keep our free trial for still more time. That's the only thing. Now I have only 9 rows where it is having a data set. It's like something like an employee, first name, the department to which the employee belongs, and when they started working in that organization. That's how the data looks like. Now we'll try to load this data into BigQuery. This is currently in my laptop. So let me try to load it. How to do it? Let me show you. Now, and you can play around with this, folks. Hide, show, all those things. If I hide it, it's going to give me a better real estate to show you some stuffs. Now, you can minimize this public data set if you want. Now, we have to create our own data set. So it has to be in my project only. So when I click on my project ID, it shows resource in this project. There's no data set available. So you have to create your own data set. So create a data set. This is the place where the data gets stored. Now, this is important when you're doing any implementations or demonstration. Assume if you're going to do it for European customers, make sure you choose the right region. So I can just give it as batch 6 is, sorry, batch 6 as my batch 6 underscore ds for dataset. Batch 6 is my dataset name, and the location is very, very important, and it is called as data location, folks, where the data resides, which you are going to load. So if you just leave it as default, the default is going to be US, United States. Otherwise, you can explicitly mention it. Now, if you look into the list, right, BigQuery offers in 2 styles. The data set can be a multi-regional, US, United States, or in European Union. It provides you in 2 different flavors. So 2 offerings, multi-regional offered in US United States or European Union. This is multi-regional. It also provides you data sets in a region specifically. Assume you are going to work for a customer in Asia, in Mumbai. You select Mumbai as a region. So this is going to be regional. So it is available in 2 flavors, BigQuery, data set. It can be multi-regional only in US and European Union. There is no Asia currently. Maybe in future they may bring it. No dual region. It is regional is available. So it's basically a multi-regional or a regional resource. I'm going to put it in Singapore. We may create some demos there. So I'm going to create a regional data set. Good. Now for a minute, assume I'm going to do it for a country in Europe where there's going to be some strict policies like data privacy policies like GDPR, General Data Protection Regulation. So let me take, for example, London, folks. Let me take London. Now, one of the clause in GDPR we usually which mentions is the data, if it's deleted, it should be completely deleted. You should not have any residues of it. So that is what it indicates. Now, if you're going to do it for a customer like this, make sure how many days you want it to be expired. After this many days, it should automatically expire. The table should be completely vanished. That is what you wanted to do. So you can do this very clearly here. So if you put never, the table is never going to be expired. If I put number of days. So we'll put it like 10. We'll put it like 10. So whatever you do after 10 days of creation, it's going to be automatically expired. So which is going to be one of the clauses for your GDPR requirement. The table is going to be completely removed, folks, after 10 days. Maybe you can use this for your ad hoc workloads, save cost, because if you just keep the table, your storage cost is going to be there, and you know you are going to do this proof of concept only for 5 days. Keep it as 5 days. Keep it as 5 days. So what's going to happen, or 4 days, whatever it is, keep it. What's going to happen basically, when you come back after 4 days, the data is going to be completely vanished. So could be a handy option. So use this. And there was a question related to this in the exam for me. So how can you automatically expire your table content? You can override this if you want to retain the table for a longer time. What you do is, any table which gets created in this data set should be automatically expired after 4 days, meaning the data is going to be deleted completely. There are some better options which we'll explore slowly, but this option, if you do it, any table which is there in this data set called as batch 6_ds in London, it's going to be completely vanished or expired. So Kumar had a question about the encryption. So this is where you see it. Data is encrypted automatically. You have two flavors. One is Google Managed Encryption Key. The other one is Google Customer Managed Encryption Key. What you don't see is customer supplied encryption key is not supported still. It is in the roadmap. That's what I heard from one of the consultant where I did some work. So he told it's going to come. They themselves had requested to Google, so they told it's coming up. So it was actually last April is what I heard this from that consultant. He was in London actually. So but still now it has not come. So some features may take longer time. So I'm not sure whether it is still available, because only if it is available we can see it. It's not there. So currently BigQuery supports only Google Managed Encryption Key. That's the default one. If you want customer managed encryption, you can use the one. I guess we did this demo for our Google Cloud Storage bucket. You can do that. So if I select Singapore, I may have a key. I may have a key because we had created a customer managed encryption key in Singapore. It goes to come. So I'm going to keep it as default, Google Managed Encryption Key. 4 days. Any tables which you create, it's going to be 4 days or 5 days. So let's keep it as 4 days, meaning next Saturday when we come, the tables which we create today should be expired. That's the key part here. And that's the reason I'm keeping it short, so that by the next Saturday you come, it should be expired. Click on create data set. Now the data set got created. So now if you just look into this icon, folks, you can see that icon of the data set. That's how the icon looks like. So data set is created. Now inside the data set, you have to create a table. Then only you can store the data. Now when you click on the data set, it gives you that information. This is the data set created on this. The beautiful feature is it is showing you the table expires in any table which you create in this data set is going to expire 4 days. 4 days. Now we don't have any data table. Let's create a table. So to create a table, people make this mistake when you do it in the UI. In the command line, it's easy, but when you do it in the UI, don't click on your project. If you click on the project, you can create only a data set. Only if you click on your data set, you can create a table. You can create a table. Okay. So if I zoom this, make it better, Control++, this is the button. So create a table. So if I click on create table, it's going to show me a wizard or a form which shows how to create a table. And we'll do the similar stuff in our command line also, don't worry. So there are different ways you can create a table, folks. You can create an empty table. You can create a table which is going to be having some data in Google Cloud Storage. You can upload it from your local machine. It could be from your Google Drive, or it could be from your big table. Now this is the same thing which I had mentioned in the slide, the federation concept. So if it's going to be an empty table, upload, it's going to be coming from your local system. Google Cloud Storage, Google Drive, and Bigtable are going to be external tables. Federation is going to come into picture automatically there. Federation is going to come into picture automatically there. So what we will do is we will use this option of upload, because the data, the CSV file is in my local system. So I have to upload it. So let me click on browse. So it goes to my this thing. So I'm going to take this console. So why I have mentioned that? So you have to load this in the web console. So that's the reason. So the table or the CSV file which is having the name Cloud Shell, you can load it in Cloud Shell. There's a specific reason why I have mentioned it like this. You can get this in your Google Drive. So select it. It is automatically going to find out the format is CSV, not a rocket science, very simple. So by just looking at the extension, it can do. And there are other few extensions which it supports. Avro, JSON, new line delimited, Parquet, ORC file formats. So we'll explore all these file formats soon. So this one is CSV. Now the moment I mention all those details, my table type is going to be called as native. If I just mouse over on it, it's going to give me some tip. Native tables are tables that are backed by native BigQuery storage. So there's another option called as external table. So what does native table means? The table content is going to be in your BigQuery itself. So the BigQuery has two components, right? Storage and compute. Both are going to be now backed up by BigQuery itself. So if it's native table, it's always going to be a little faster, folks. That's it. Latency, because they're connected by petabit network, all those things, it's going to be faster. So that's it. So you uploaded it. You see it is a native table. It indicates what's the project you need to work on. What is the data set? Just give a name to your table. So this is looks like an employee table. So I'm going to give it as employees table. That's it. Now you have to give some schema to load the data. So you have to mention what is the kind of data you are going to load. So looking at this file, first name is a string, integer, department is a string, date, start date is a data type. So basically 3 data types is what you need to provide. Let's give that. We can give auto detect, but I don't want to use it now. We will use it in a later demo. So we'll add 3 columns. We'll add 3 columns. First name, and you can see the various data types BigQuery supports. Around some good amount of data types are supported. If it is not there, you have to find out a map. For example, in a database, if you see something like variable character, varchar, it actually maps to string. It actually maps to string. So mode, when it can be nullable, repeated, all those things, I'm just going to leave it as nullable. It can be null. It's a small data set which we have. The next one is, I'm going to do a small change. Department ID. I'll also have some naming convention, folks. Camel casing. So where the first letter is going to be small, the second letter is going to be up. So like a camel, the hump in the camel. So this is going to be an integer. The last one is joining date. I'll make it as joining date. Joining date, and it is of type date. And to be very frank, folks, people who have worked on database, data warehouse, they know the most troublemaking data type is always date. Whatever you be an expert, you'll definitely make once a mistake with the data type, which is date. This is always a troublemaking data type, folks. Parsing, always you'll have issues with this data type. String is the one which will never have a issue itself, the smoothest data type. String sometimes, but date, timestamp is always troublemaking types. Just for your information, people who have worked on database, I would say they would definitely agree to what I'm saying, because that's always a troublemaking one. So just an information. So that's the columns which you wanted to do. Now you can just click on this button to show you that format also. So there are two ways where you can give the schema, something like column name, data type, comma, other columns. So you can mention it in this fashion also. So in this fashion also, or you can add it manually. So this is it's just a user interface basically. So since we have three columns, we have created three columns in our schema. Now there are some advanced concepts, partitioning under partitioning and clustering, which we'll talk tomorrow. So I'm going to not even touch that. I'm not going to even touch that. And I'll go to my advanced section. Advanced section, there are lots of stuffs. We'll not explore everything in one shot. We'll explore one by one. What we are going to do is the delimiter. So there are different delimiters available. Our file is going to be comma separated. So that's the default one. I have done that. Then if you see your data, the first row is a header. The first row is a header, and I don't need to import this. This is only for me to understand, for a human to understand what does this value mean. So I should not load this into the system. If I load it, it's going to throw me an error because it's a string. But I mentioned department is integer. So this is an header which has to be skipped. So you mention how many rows you need to skip. One row, 10 rows, whatever you want, you can mention it. One row is the typical one. So one row, you have to skip it, the first row. That's it. And the table which you're going to create is also going to have an encryption setting. So you can mention the table which I'm going to load should have an encryption, which is going to be Google Managed Encryption. That's it, folks. Let me just repeat it once because it's the first time which we are doing. So upload option, browse the file which is there in your local system, mention the table name. The schema part is an important one. Then the header part. So you need to mention the number of rows which you need to skip. And there are other fields which we will talk later at a later point of time. So that's what I have done. Now, if I click on create a table, if my steps were all correct, it should show table created successfully. So it shows table has been created. The employee table is created successfully is what it indicates. Now, if I go expand my data set, you see the icon difference itself. So these things could be very basic, but sometimes when you are totally not from this background, the icons at least is going to help you out. It looks like more like a calculator kind of icon, and the data set looks like more like a building kind of an icon. They could have had some better icons, but that's the thing which they have. So now your table is also created. Now, if I just go click on this table, I will see the schema. The one which we mentioned, you see those schema. Clicking on the details, it is going to show very clearly. It is going to have only 9 rows. We know that because we saw that in our notepad. So it's only 9 rows. It's only 9 rows. And created on so and so time. The most important thing is this table is going to expire. Whatever you do, whether you query it, you don't query it, you don't do anything also on 28th of April at 8:32, because the time currently which I created was 8:32 only. So it's going to get expired, meaning the complete 9 rows, 212 bytes of data is going to be removed. And the data is currently stored in Singapore. So this is what it indicates, 9 rows, and total size is 212 bytes. Now, out of curiosity, right, if you want to know how this 212 kilobytes came, small activity which you can do is, so if I click on this one, if you go to that level of fine granular stuff to analyze how the size looks like, right click on this, go to your properties, you will see the total size is 215 bytes. Where is the 3 bytes missing? Any idea, folks? The entire data set is 215 bytes. But when I see it in my BigQuery, it shows 212 kilobytes. Sorry, 212 bytes. Where is the 3 bytes went? Any performance optimization? Yes, so that's correct, Kumar. So basically what it did was the first row was skipped. So that 3 bytes was taken off basically. So if you remove this, if you just remove this, save it, now look into the size, it should be okay. It somehow came down to less. It came up to less. Okay, so at least that reduction is there. So it's going to be a little more is what I understand. So basically that is where the difference comes into picture. So if I removed it, it became reduced, but now I don't have an answer. So, but out of curiosity, if you were to do all this kind of stuff, so you can do it here. So let me put it back. So now the data is there, folks. Now 212 kilobytes of, sorry, 212 bytes of data. You can also click on preview, which is totally free. You can see it. But if you want to query it, you can also query it. So click on query. Now we know we will never put select star. So you can either go to your schema, click on the columns, it's going to come, or you can type it. Auto suggestion is going to show up. Uh, it used to show. Okay, you have to hit the tab. So auto suggestion is going to show up. It's going to show that. So now out of 212 bytes, because I put only 2 columns, so it's going to be 140 bytes, 140 bytes of data. That's it. Run query it, you should be able to get a response. Now, this is not a great demo, I would say, but what we did literally was, learned how to load our own data set. Now this entire process which you did is totally free, loading the data, because loading data in BigQuery is free. That's what we saw in our slide. So this is not going to cost any charge. So you want to verify that, you can just go to your job history where you loaded this data. It's going to show you the details, but it's never going to show you any price information because loading data is totally free of cost. But if you go to your query history, you just queried it, you queried first name and department, it had only 140 bytes of data. But in BigQuery, the billing model is always minimum is 10 MB. So they charged 10 MB for us. So querying is going to be cost depending on the type of data. But if you basically load the data, it's going to be totally free. Totally free. Now, if I go back, to the same query, first name, department ID, it's going to show 140 bytes of data, all those things, right? Now I already ran it once. Now, if I run it one more time as the same user, let's see what's going to happen. If it's possible, it's going to take it from a cache. Sometimes it may hit the backend system and again get the response. So when I ran it, it told 1.1 seconds and around 140 bytes of data process. Now, if I run it one more time, it's going to show it did not even took any time because the data came from cache is what it's going to show. So it's not always guaranteed, but if there's a cache which exists, it can query it and show you the results. It can show you the query the results and show. So this time, so and by default, this cache is going to exist for 24 hours. And this cache is basically per user level, folks, not at a project level or anything. It is going to be per user level. Meaning if I just go to my query history, I see this query, it shows results are cached. And if you see the previous query, it shows it hit the backend and got the result. So this is going to be per user level because it shows who ran the query. Mahesh. So this is going to be per user level. Now, if I give you access and you log in and run the same query, it's going to again hit the backend and get me the result. So I'm going to be charged twice. Same query, but queried by two different people. So I'm going to be charged. Now, any thoughts if you can make this reduce, folks, based on the concept which you have learned so far? Caching is going to be per user based. But I don't want to incur cost. So assume I'm employee one, you are employees, other employees. All of us are always going to run the same query. But all 10 of us or 20 of us run it. It's going to be 20 such queries. I'm going to pay 20 extra, 20 times the price. Can I make it as one? But I cannot give the same, I cannot share my username password with you people. So you have to use your own username password, uh, so that violation will not happen. But is there any other option where I can reduce it to be only one user somehow? Should I create a common user, something like that? Shareable named query. Hmm, never heard that, Anil B, whether there's something of that sort. Have you explored it? I never saw something like that. Okay. Okay, I thought there's a new feature which was there. Okay. uh, how do I reduce? It's basically somehow if I can make this user ID same, a common user ID, something like that, I can reduce it, right? Any thoughts on that, folks? You have learned this. You have learned it. Service account. If I can give a service account a capability to query it, and assume I build an application. So if I go to that application, click on button, it's going to send a query, and that application is going to use a service account to query my BigQuery. So it's going to be one, right? So in the entire day, if you run it 10 times, 1,000 times, it's going to be always cached. So now you see how you can use your service account even in a BigQuery stuff. So makes sense, right, folks? If you use service account, it's also going to work. So it's going to query it and give you the results, and it's going to be cached. So if you have such requirement, now this is where an architect comes into picture. So you don't need to be an expert in querying. That's not our job. So that's going to be done very well by a person who knows SQL statements. But we, as an architect, can position our service account, maybe build an application in Python or whatever it is, query it using a service account, then your cost is going to be reduced to a great extent. Great extent. Same approach, you can also use it in BI tools. There are certain BI tools which help you to authenticate using a service account. So if you do that way, right, that's going to be an awesome option where you can save a huge cost. And there are certain BI tools which always allow you to authenticate using a user only, username, password. It should be a human. Some BI tools provide you a support for service account also. So that way you can reduce your cost. But the only thing is that you will not, you should make sure you only provide them access to only query it, not alter the data. Because if you use the same service account, if they modify something, you'll not know which user did it. So that IAM, principle of least privilege, still applies there. Okay. So if you are very curious, where is this table stored, all those things, because it is coming from cache, the table name is called as this one, temporary table. So if you click on this, it takes to some weird data set, which you will see. Look at this data set name. If you click on the details, it is not your employees table, folks. Look at the details. It is going to be totally something very weird, but it's going to be in your project ID only. This is my data set. This is my data set name, and this is my table name. N-O-N-A-N-O-N, anonymous table. So this is going to be called as anonymous table. And anything very specific do you see about this table, folks? What do you see specifically about this? Forget about the name. Anything unique which you see in this table? Anything unique you see in this table, folks? Size, table size 0. Okay, good. Anything else? Anything else? The table size 0, that is true. Anything else? More than that, there's an important stuff. Location was same, Kumar. It was in Singapore, same as the location. Actually, expire in a day. Yes, Sridevi, that was the awesome feature. So we told cache is going to be valid only for 24 hours. So it's going to be expiring in a day, meaning this anonymous table is going to expire automatically in a day. So this is the reason why your cache gets expired in a day. So uh, uh, connecting the dots, and you already use the expiry capability. So you see that it has been already used. So the table gets expired. So now if you run for the entire day, it's going to be querying this table most of the time. So meaning it's already processed. So you just read it. So this is going to be coming from the cache. So it's going to be totally free for you for the next 24 hours. So tomorrow at 8:38, this table is going to go off. It's a table which expires in a day. So that's something on your tables, folks. Like how do you load it, all those things, query it. We loaded a very simple data. So what we will do now is we saw how to load it in a GUI, web console. It was very straightforward, easy option. We'll take a okay. Maybe okay, folks. I had to. Okay, we'll take a break now. So once we take a break and come back, we will see how we can basically load the data into an existing table. And we'll take a 10 minutes break and we'll stop it at 9:30 Indian time, folks. Because there's a lockdown in Bangalore, so so I had to buy something. So I have only 30 minutes to go and buy it. 10 o'clock every shops will stop it. So only for today, folks. 9:30 we'll stop it. Okay, so we'll take a 10 minutes break, come back and do one part or two parts of the demo, and 9:30 we'll stop it. Okay, stop the recording.
This conference will now be recorded.
So before the break, we saw how to load a data from our local system. So now assume this is going to be like a routine stuff where you are going to load the data every time. Assume this could be a data coming from a HR feed. So currently we have 9 members. Few more members joins. For example, if I open up my Cloud Shell, so 3 more employees join the organization. It's a feed which you are getting it from your HR. So 3 more people join. Now you don't want to use UI. You want to do it in an automated fashion. So that's the reason you want to go with basically command line mode. No transformation and all we are doing, we're just loading the data. So tomorrow we will see, or maybe next Saturday we will see how to do transformation on this data. So this one, HR gives the data, I automatically load it using a script. So anyway, we learned how to load it using UI. Let's see how to do it in the command line. Okay, so for this one, how to load, make sure I'm going to use Cloud Shell. So in Cloud Shell, we are going to use a utility called as BQ. So this is another important stuff, folks. There's no Gcloud command is going to be used when you're interacting with BigQuery. So for example, maybe I can make it very clear in the cheat sheet so that we don't make any mistake here. So if I just put an insert a row, yeah, this many rows. So utility resource, let's call it as resource, and utilities, utility or command used. If it is most of the GCP resources, okay, I'll put this towards the end. So if it is storage buckets, what's the utility which you are going to use, folks, for interacting with storage bucket? Interacting with GKE cluster, interacting with CBT, interacting with BigQuery. Most of the GCP resources except the above resources, except the above mentioned one. So if it's storage, as most of you mentioned, it's going to be GSUtil. If it's Kubernetes cluster, folks, interacting with the cluster, basically it's going to be your kubectl. Yes, so kubectl or kubectl, whatever you want to call. For CBT, what is the one? Okay, Vivek gave everything in one line. Good. So GSUtil. So it's going to be CBT utility. When it comes to BigQuery, you are going to use BQ. Very, very specific, folks. So even if you get a very basic question, how do you interact with BigQuery or anything, you should never ever use Gcloud command, folks. The rest, yes, Vivek. So the rest is going to be Gcloud. A small lookup one, folks. Maybe, who knows, you might get a very basic question like the how many VPCs which we saw in our morning class. So morning session. So make sure you don't lose a marks just because you slightly got confused. So it is always going to be using BQ utility. So now what we are going to do is we are going to use load it into our existing employee table using BQ utility. So let's try to do that. So I'm going to use the BQ, which is going to be in my Cloud Shell itself. So I don't need to install anything. So I'm going to use my Cloud Shell. And all those commands are there in the cheat sheet. You can look into it also. So if I go to my network big data, this is what we are going to explore. Bulk loading. BQ load project ID, BQ load project ID, the table name, details if you mention, and the CSV file. It's going to load. It's going to load it. So let's try to do that. So now if I show my table, this is the table. Before I load anything, let me run it once, folks. Let me run it one more time, the query. It showed it is coming from cache. It shows it coming from cache. So we took 10 minutes break also. So it shows it is coming from cache only. Second time, n number of times I run it, it's going to coming from cache only. Now, as long as your table is not modified, it's going to come from cache. But now you have 9 rows. The moment you add 3 more employees, it's going to become 12 rows. The moment the table gets added, the cache gets invalidated and you will not even have it. So as long as the table is not modified, the cache is going to work. So wanted to show you that also in action. So 9 rows are there. Now what I will do is, I don't have that file, folks, in my local Cloud Shell. I'm going to upload it from my local machine. So BigQuery Cloud Shell. Done. So if I put ls, I should see my file. Good. Now, if I want to see the content, it's the same content, 3 rows. Now let me show you how to load it basically and see whether things are going to work or not. So you can interact in command line using the command called as bqls. If I put, it's going to list all the data sets which I have. I have only one data set. Now if I put ls, the specific data set, list whatever is there in this data set, it's going to show list the employee table. Now if you want to know the details about the employee table, you can type something like bq show dataset dot employees. So if I do it, it's going to show me the what is that, the details tab which you were trying to see, the details and the schema. it's going to show the table was created so and so time, schema is this, number of rows is this, the bytes are this. So this is how it's going to show. Now, if I want to load the data, I'm going to do BigQuery load. I don't need to mention the project ID because my project ID is already set in my Cloud Shell. I don't need to do it. Otherwise, you can also pass it if you want. You can also pass it. So I'm not going to pass it now. So I'm going to use BigQuery load command followed by the file name. That's it. Let me hit enter. See whether it is loaded. Did not throw any error. It looks like it has been loaded. Looks like it is loaded. Now what you can do basically is go ahead. Okay, you can see the show command, right? Show command. Now the number of rows should be shown as 12. 12 rows. 12 rows are there. Now, if you go run this query in your console, it's going to show it is not coming from cache. It's going to hit the backend because the data has been modified or the table has a new set of data. So it's not going to still have the cache. The cache gets invalidated. Let me run this query. Now it's a new query. So it queried it and you see 12 rows. And you should see people like Mahesh, Harry, and Suresh, who are the new employees who joined. So you will be able to see it. Now the cache gets invalidated if the table gets modified. You understood. Cache is per user. You understood. Cache is valid for 24 hours. If the data is not modified, you understood it. And you also understood how to query it using the command line utility. So is this part clear, folks? So far we did not had even a glitch. So it was so seamless, it was working. So thanks, Mangesh. Others, is it clear, folks? What we have done so far. Thank you, Anil. And thank you, Vivek. So till here we have loaded it. All good. Let's have some issues first. Let's create some issues. Only then we will learn something. So if it is like a movie which has no villain, it's going to be not a good movie, right? So it's not going to have that curiosity. So let's have something which is going to be some troublemaking stuffs. So let me open up this third entry, and let's assume this kind of CSV file are going to be shared by a human, basically from the HR or from the staffing team. And there's a chance that people can do mistakes while doing the data entry. Now we have got a third set. Which is Raj, Buggy Person, Lokesh. We need to load this data. Now I'm just going to give you a minute to check what's issue in this. And I've also already given you a hint. The data which is going to have some issues are going to be Buggy Person. So what is the issue there? Kumar gave it, Anil B gave it, uh, uh, Vivek gave it. Mangesh, why it's an extra column? The month is wrong. Yes. So basically, most of you got it. By doing this demonstration, what you are going to understand is this is going to have some issues. And before doing this, a small information, BigQuery's format. I told, right, date is the most culprit. This data type is the most culprit. It's going to create always a trouble. So the format in which BigQuery accepts the date format is YYMM DD format. This is the format it accepts. If you send it in some other format, it's not going to accept it. So but if you see this one, this is in we don't have a 13 months, fortunately or unfortunately. So this is going to be in this format. So this is in the format currently this way. So BigQuery cannot accept this. So let's see what is going to happen. What do you expect, folks, if you have something like this? So there are 3 rows. What's going to be your normal expectation as a normal person? Forget like a cloud architect, a business person. from the business perspective. If there are 3 rows, 1 row is buggy or having issues, when you load this, what is going to be your expectation? What would be a normal expectation when I load this kind of data? Throw error, just stop, reject 1, commit 2. That's going to be the normal expectation everybody would expect. Okay, yes, just because one person is having an issue, we should not block the entire stuff, right? Reject buggy person, add to Raj and Lokesh. That's going to be the normal expectation. That's going to be the normal expectation, right? Will not load at all. So not loading all is not expected, but we should, that's going to be, we'll see. But the expectation, a normal expectation is, yes, out of 1,000 records, 1 record is wrong. So discard it. At least insert the 999 rows is what normal people will expect. Let's see whether our BigQuery BQ utility can do that. Okay, let's do that. So again, I had to upload this file. I don't have it in my Cloud Shell. I'm going to upload it. So upload. All right. So ls. Oh, sorry. I have that buggy entry. So that's the entry which you have. So let's try to run the same command, not even a single change. I'm going to run the same command. Oh, sorry. So this is the command which I'm going to run. So expectation is 2 rows added, 1 row not added. Something like that is what is the expectation. Let's see. Same command which worked previously. Let's see what is going to happen. Now it throws me an error very clearly, unable to pass the date. It gives you tells errors with reading the error message, too many errors, giving up, rows 2 error. What is that? Not able to pass it. You are loading the data without specifying the date format. Date will be treated as CSV by default. If this is not what you mean, you need to specify the source format. So it's giving us some information which you need to make sure this is how the format is going to be. The date format is going to be what format it's. So if you don't specify any details, if it's having some issues like this, you will not be able to insert anything. Everything is going to be failed. Everything is going to be discarded. If you want to verify it, run your show table. It's going to show till 12 rows only. 12 rows only. Now there's going to be a flag which you can use basically to play around with such things. And this is going to be a by error and trial only you're going to get how many. Now you may say out of 1,000 rows, if there's X number of rows, 10% or 1% is going to be always buggy. So give that as a rule to discard it. So what you can do is, in our case, it's 1. So maybe you can treat it as 1% of the data is always going to be error. So you mention that very specifically in your query, saying that discard these many maximum bad records, then load it. So I can mention a flag, something like max bad records. How much you need to discard it, you can say it. How many rows you want to discard. Max bad records 1 or 100, whatever the number you pass. So if it is within this, any data which you are going to load is going to be loaded successfully. So I'm going to mention it as 1. By default, this value is 0, folks. This value is 0. So you may be tested on this kind of questions in the exam. So max bad record set to 0. Can the data get loaded without any error? If it is all with a valid format, it's going to get loaded. If it is having errors or format issues like the one which we have, if I run it now also, it's going to throw the same error. It's going to throw the same error. If I show the tables, it's 12 rows only. Now, you should always send a non-zero number, only then it is going to be valid. Remember that. This was a question which I got something similar. So just wanted to show you, create a scenario, a story behind it so that you can understand it. So now let me try to run it and see what is going to happen. I'm saying Out of these records, one can be buggy. Now the error itself is going to be totally different. It shows it has done some few things, and it also shows some of the records I was not able to process it. So it shows this error message. Now you can redirect this error message to a log, read this log information, and then fix it. You can do that. The best way is to have some kind of a ETL tool to fix it. That is also something you can do. But now we have not using any ETL tool. Tomorrow or day after, tomorrow or on next Saturday, we may use a ETL tool called as data flow. At that time, we can see how we can do all this kinds of parsing. So with the limited commands which we had, we were able to use this flag called as max bad record to discard any rows which is having some issues. Basically, now if I do show the details, it should show basically 14 rows. 2 rows are added, Lokesh and Raj would be added. So if you want to see that, if I run this query, 14 rows are there. Raj and Lokesh are also added. So now we started with some issue. And we saw how we can use that parameter, max bad records parameter. By default, it's going to be 0. We gave a non-zero number and we were able to fix this. And how do you get this number? It's going to be based on an error and trial or some percentage you decided. You put it. So if you don't put it, it's going to be 0. It's going to be 0. So since I got this question, I thought at least I'll share you that something which is going to be helpful if you get something like this. I just copy this command, folks, so that you know this is important in our cheat sheet. Okay. Discards one bad record. So hope this is clear, folks. Hope this is clear. How do you play around with BQ utility and also handle some errors? Now, if you ask me, can this handling of error can be done in command UI also? Definitely, it is possible. So the max bad records. So if I try to do the same thing, so if I click on create table, in your advanced section, in your advanced section, I have to load first. Buggy, I'll just again load it. Buggy, I'll mention it as employees. I'm not going to create a table. So buggy, I will use my schema details, which I already have it. What I'm going to do now is in my advanced section, I'm not going to write it to an empty, but I'm going to append to an existing table. This is how you load to an existing table in the user interface. So you have to click on create table. There's no update table option. Upload it, your buggy stuff, give the name, employees, the schema, you have to mention it. It's going to come up under your advanced section. By default, it's going to be always write with empty. So, but if I make it to append to an existing table, it's going to append it, and the number of records errors allowed. This is the same thing which you get it as a flag. So the number of max errors allowed. Anyway, I don't have a header. So if you see the header, there's no header. So I don't need to use that header. So you get the option both in command line and user interface. So any other ignore unknown, if you when enabled rows with extra columns, this is another feature. So there's another feature which you can use. Some extra columns, if it is there, if it's not going to match, it's going to be also ignored. So, but the number of errors which you want to allow totally, I'm mentioning it as 1. This is equivalent to your -- max bad records. So let's see whether we can insert it. Now, one important thing in BigQuery is there's no concept of primary keys. You can insert the same data multiple times. So what's going to happen? Now you have 14 rows. Now if I run this and if it runs successfully, it's going to be 16 rows. Raj and Lokesh are going to be added if things work here. It's always going to be in append mode, and it's not going to see, oh, Raj is already added, Lokesh is already added. It's not going to update it. It's always going to be by default append. It's going to keep adding a new row. There is an up command called as upsert, where you can do those merging all those things. But for now, let's just append it to the existing data. So let me click on create. The highlight of this demo is going to be this append to table. Let me click on create. Fingers crossed. I never did this demo, so it was the first time I'm doing this. Okay, it shows it has been done. Let me see whether it is going to show 16 rows. Beautiful. It shows 16 rows. Now, if I look into my preview, I will have 2 Raj, 2 Lokesh. So I hope this concept is clear, folks. How you load to an existing table, how you load it from command line and from your user interface. If it's user interface, you have to always use the option of append to a table. Is this part clear? So it does not check duplicates. No, it does not check it. You have to have some extra logic to do that. Maybe at your ETL tool, or once it is inserted, you do some quick sanity check and do some upsert. There's a command called as upsert, which you can use. So, but by default, it does not do any check for duplicates, because the source coming is from a database where it may not have any duplicates. Basically, it assumes that. So if you want to handle it, you have to handle some with some extra logic, Kumar. Okay. So we saw till here, folks. We saw till here how to load data, CSV data only, using BQ utility, and also handle some errors. And we also try to load the data into our using our console also to an existing table, not a new table, to an existing table. So we'll stop it here only for today, folks. Sorry for that short notice. We'll stop it here. Tomorrow when we resume back, we will see how to load some other formats. There are some other popular formats, JSON, Avro, Parquet, ORC, and which format is going to be the best one. We'll also see that, and then we'll get an idea whenever we are doing with BigQuery what should be the best format for loading. We'll also do that conclusion there, and then do the remaining parts of the demo. Okay, so we'll stop it here. Tomorrow, if you have any questions on what we did today, I can handle it. Only for today, just give me 30 minutes. I'm just going to stop it today because, as I mentioned, there's a curfew, so I have to do anything without from 6 to 10 only I have to do. Afterwards, they are going to have a curfew in Bangalore, at least in Karnataka. So I have to make sure I go buy some glossaries and come back. Okay, so we'll stop it here today, folks. Resume back tomorrow, and sincere apologies for that short notice. Okay, same in Pune also. Okay, so hope we come out of this soon, folks. Thank you, folks, for your understanding. Let me stop the recording.